Sanmit. Sanmit. Mr. Rudrapaya, Managing Director, Credil. Please. Dr. Sitaraman, President, Fema. Please. Mr. Ganesh Rao, Vice President, Kasia. Please. Okay, sir. Okay. Thanks for sparing some time for us. Mr. Madhusudanan, Regional Director, IGCC, Indo-German Chamber of Commerce. And we have Mr. Sanjeev Baitmangalkar, Senior Consultant, Stratman Consultancy. Mr. Alpesh Mehta, please do come soon, from Siemens. Mr. Kiran Mazumdar, please. Mr. Kiran Mazumdar. So with this, I think we have key members on the stage. I would now request Mr. Madhusudanan to kindly take over from here on. Madhusudanan, sir.
So I request all the dignitaries to come down to light the lamp and then before we start the proceedings, please. Thank you. Let it be here. Yes. Good afternoon, everyone. So it's really a privilege to stand here before you all today as we kick off this MSME Energy Efficiency Workshop. This is a day dedicated to reimagining the future of energy use in the heartbeat of Indian industrial ecosystem. None other than the small, medium, and micro enterprises. Before we dive deep into the agenda, so let me share a little backdrop of how we came up with this thought and wanting to do this kind of session. So myself and Mallikarjun had the fortune of having a detailed discussion over the last couple of months to see that what we could do further. And in that process, we have been visiting some of them as well. I had the fortune of visiting some of the MSMEs, not from Karnataka though, but I was just actually checking. I had this opportunity to visit a small spinning mill, which has close to about 40 machines, machine setup. It's a family-owned company, and it's passed through generations. So the small firms, it is really filled with the hum sound of those spindles in the air, and the workers were really rhythmic. While this is not a updated technologies or the new technology which has been in use, but the things were going really smooth and quite in a rhythmic fashion. In one of the corner stood a control panel where you have this continuous monitoring of the logs were written there. The energy logs were written there, and with the power readings, right? And there was also a caption which is actually in Tamil, but it translates something like this: that a rupee saved in energy is better than a rupee earned in sales. So this is what is roughly translates to. And I curiously asked, how, because the cotton mills are going through really a tough phase, and how this particular organization has been able to keep up and stay competitive despite the rising cotton prices, energy costs, market pressures, everything. So he really smiled, and he was telling me that we can't control the price of cotton or the market, but we can control the energy and efficiently run our operations. So he told that they have found that the motors were oversized, the compressors were leaking, the lighting was running continuously, and so they did not do everything overnight, but I think slowly they implemented, and just one small step at a time, and they were able to turn this organization a lot more efficient actually. What struck me is actually they big consultants to come and tell about what someone needs to do, or they did not wait for a government scheme, but they started with awareness. They measured, they experimented, and slowly I think they built a culture of efficiency. I think this is what matters, where every unit of energy saved was seen as a win. So this is what they tracked. That's what it's about today, actually. So we are not here to lecture. We are not going to give a monotonous delivery. It is going to be a workshop model. It's a safe space where you can pause from your daily grind. I know how tough it is for an MSME organization. Free your mind space and observe new ways of thinking. Because sometimes all it takes is a fresh thought or a new look to start something, look at new possibilities actually. So I would like to extend my heartfelt thanks to the MD Cradle, Mr. Rudrapaya. The thing is that when we approached him, he did not even had a little bit of hesitation. He's all open and told that he's all in for this, and he was ready to support us throughout. And the next goes to the president of CASIA, but he's not going to be there today, but Mr. Ganesh Rao is represented. He was also fantastic. So when we approached, he was a lot more forthcoming to reach out to the MSMEs. And Ms. Sita Ramu and Mallikarjun, I cannot tell more in words about them, because the kind of discussions which we had, the depth of engagement, the finer details, how we wanted to do it a lot more engaging. So I think we have a wonderful team with us. This is going to be a journey. It's not going to be a one-off session. So we will be doing multiple sessions from here on, see that how we can drive like change at the grassroots level. That's our whole intention. And and Mr. Sanjeev Bhatt-Mangelkar, like, you know, how can I, like, you know, I mean, he's one of the leading experts here in this phase, senior consultant, and happy to have you, sir. And Mr. Alpesh Mehta, country business head, Siemens low voltage business, I think LVM, and yeah, so the Kiran Mazumdar from TOR AI as well. So thanks for supporting us and looking forward to have this wonderful journey with you all. Only a couple of sentences before I leave. So I encourage you, each of you, to free up your mind space. Don't limit yourself with this thinking that, you know, this is or this won't work in my setup, or we don't have the resources. Be open, be curious, and be bold. So this is what I would want to leave out with. And let this workshop be a first spark in our journey towards energy efficiency and sustainable growth. Thank you once again, and let's make this day count. Requesting Mr. Rudrapaya to share a few words before we start the proceedings, please. Thank you.
ಎಲ್ರಿಗೂ ನಮಸ್ಕಾರ. Good afternoon, everybody. The other day, Mr. Madhusudan, Regional Director from IGCC, Mr. Sitaraman and Mallikarjun came and met me. As Madhusudan mentioned, I said he just, they requested for our presence, Credal presence. I said, we'll be part of the program instead of, just coming. I think that must be the reason our logo is there in the program. So we all hear about net zero. Entire world is talking about net zero emission by carbon emission by 2070 and something like that. And some European countries have already committed that by 2040 or 2050 they'll become net zero. And so India is also part of the Paris Agreement, and we have committed that by 2030 will be 500 gigawatt. And we have already touched around 225 gigawatt by now. And every state has got its own plan. And of course, Karnataka has to lead by its example. We are already 22 gigawatt as far as RE is concerned. 63% of the energy is coming from RE sources in Karnataka. So that is where we stand. We stand in number 3 position. And as far as energy conservation is concerned, net zero cannot be done by only generation. It has to be, the conservation has to be play a very important role. As Madhusudan was mentioning, like in other way, like we can put it as like one unit of energy saved is equal to 2 amounts of generated. So this conservation and efficiency plays a major role, and especially MSME will play a major role because in the entire nation or the state perspective, MSME has got its own importance. That way, the effort of IGCC is very commendable. You have chosen the right subject, and I hope this workshop will be very meaningful. And as Credal, we are the nodal agency for Bureau of Energy Efficiency. BE operates at the Government of India level, and Credal operates, implements all its schemes in the state level. We are always open for any of its initiatives, whether by CASIA, IGCCI. So that's why I said our offer is open, like for any of these initiatives, whether it is a financial support or our, this thing. We have a separate wing for this. So we are always there with, organizations for these causes. I hope all of you will make use of this workshop organized by ICC. Anytime, any assistance you need in this direction, you can always approach us. We have our corporate office in Nagarbavi. It's one of its kind. Probably I request you to drop in sometime. Probably you will notice what we are doing. So you please make use of all the schemes which are available, and we are always open. I once again thank Madhusudan. Mallikarjun has taken a very important role. We're also working in different areas. Like recently we had in this hotel only, we had a conference on buildings, especially how we can conserve energy in the building sector. People from Infosys and other companies also had come and shared their thoughts. So like that, there are a lot of, we are working in agriculture sector, all the major sectors which contribute to the conservation. One interesting thing is that we always talk about net zero, but here the caption says near zero. I think Mr. Madhusudan will throw more light on this. With these few words, I thank IGCCI for giving me an opportunity. There are, elite, very experienced dignitaries are there on the dais. I hope they'll share more information to all of us. Thank you once again.
Requesting Mr. Sitaramu, President Fema, to say a few words to open the session, please.
Good afternoon. Ellargu namaskara. Dignified dignitaries led by Rudrapayaji from Cradle on the stage, all the invited speakers and distinguished delegates. This workshop is really wonderful, and we have chosen to have it on Earth Day. Today, Earth Day, April 22nd. And the slogan is a powerful slogan, 1 hour power, our planet. It is focusing on the renewable energy. And we are going ahead with that, whole country. The theme comprises of the importance of renewable energy and also the ways and means we are going to achieve. So this MSME energy workshop towards zero carbon emission is really wonderful. And I'm very happy that we are coming together. Our Indo-German Chamber of Commerce, Madhusudanji, all the government establishments, led by Rudrapayaji, Ganesh Rao from Kasia, and all the industry experts, and all the seasoned practitioners, renowned academicians are also here, and leading associations. We see so many energy audit specialists with whom we keep taking advice, including Prakash Magal. So this workshop presents a unique opportunity to co-create solutions that can transform India's industrial landscape towards sustainability and energy efficiency. Together, we can harness collective expertise and experience to drive meaningful change, foster innovation, unlock new avenues for India's MSMEs to thrive a low carbon economy. And the invitation our Rudrapayaji has given is really vital. All of us, let us accept. We'll visit, we'll have a free discussion, and the time has come to take specific actions. And my experience over the last 4 decades, we have improved enormously in terms of the improvement in our energy approach, and we are going to do it, sir. We will definitely visit you. I am further very happy that we are the forum of energy managers and auditors, newly formed FOAM as a part of the group. Fema brings together experts from the fields of energy production, transmission, distribution, consumption, and policy making to foster knowledge exchange, skill development, and industry-wide collaboration. Fema plays an active and critical role promoting energy education also, supporting professionals to continue upgrades, including soft skills, collaborating with government bodies, and creating platforms for youth empowerment. Fema also serves as knowledge partners for academic institutions and further support establishing infrastructure for innovation, including energy efficiency parks, and also calibration labs, including enabled calibration labs and process validation centers. Our team, Vice President Dr. Archana is here, Secretary Murali, Treasurer Upadhyaya, and among the active members, our pillar is Mallikarjun. Mallikarjun has come with his full family, Mrs. Mallikarjun and son Smita, his daughter. Full family is supporting energy. Thank you, sir. Good. Thank you. By leveraging energy efficient technologies and practices, sir, please. By leveraging energy efficient technologies and practices, MSMEs can minimize waste, optimize resources, and create high quality products while supporting high transition to a low carbon economy. Today we are addressing the important areas applied to industry adoption through combination of expert auditors' views and application to the products are also laced with AI perspectives, and I wish today's program a grand success. The intersection of energy efficiency, product innovation, and MSME-led innovation and growth can unlock the new opportunities for sustainable industrial development in India, aligning with country's climate goals. And with my experience at CPRI over 3 decades, and also my colleagues who are also supporting this issue, yes, will definitely answer the significant challenges in transitioning towards near net zero emissions. Thank you very much, and I wish the program all the success. Thank you.
Yeah, may I request Ms. Mallikarjun to share that what is there in store for this today, please. Session highlights.
Thank you, sir. I just set my own timer of 3 minutes. As energy auditors, I think we need to show by demonstration. So my time now is 3 minutes. I'll try to complete within that. Knowingly or unknowingly, myself and Fema members and IGCC, we finalized 22nd April as the day that we are going to have this particular first event together. And incidentally, today morning, I got to know, rather it's my lack of knowledge, you can say, that today is the Earth Day. Every 22nd April, we all celebrate Earth Day. And it is good that we are culminating our event, the first event for Mr. Madhusudan under IGCC and for Fema, the Forum of Energy Managers and Auditors. We are sitting on the right topic. Now, to talk about, like I said, people always talk about zero emissions. Now, we all know it can never be achieved. So when Madhusudan sir asked me what should be the thing, he said we can show that we are moving towards net zero, but we can never be reaching that target. So all our efforts today are going to be oriented towards efforts to reach the target of nearing to net zero emissions. Just to set the trend, usually we all know all workshops are organized in such a way, people deliver their presentations, delegates listen to what is being delivered, and end of it. There can be a question hour. Now here, today, what we are going to have is a three-way communication. Three-way communication in the sense, as energy auditors, some of us would be will be opening our opinion on the field, what we see on site. And all the MSMEs who are here, we would like you to back us with what problems you have, and we will list them on the whiteboard. And each of those topics would now be required to be answered by all the presenters. Usually presenter had an option to go through their presentation. We are all open to see your presentation, but we would like you to address the problems that are being faced by the industries on the field, so that we have one-to-one live discussion. It is not that end of the thing we are going to have 5 minutes question hour. All the 30 minutes that have been allotted are question hours. There is no format as such saying that we are not going to listen to you. But our appeal to you is, yes, let's have an interactive session. This is what we intend to set the trend, so that we have a new bonding between the presenters and the delegates. Thank you.
Yeah, thank you, Ms. Mallikarjun. May I request Ms. Dr. Archana to share a few words? Do you want?
Good afternoon, everyone. I was asked to do the vote of thanks, so I'm just going to call out a few names here. Actually, when we began planning this MSME energy efficiency workshop, we imagined a room full of change makers. And today we are here. The vision is coming true. From the insightful sessions to the passionate discussions, this isn't just a workshop. It feels like we are going to start a movement here. A heartfelt thanks to the Indo-German Chamber of Commerce, Cordially, IGEF, CASIA, and the Forum of Energy Managers and Auditors. Your support lit the spark. I would like to call out the names here. Mr. Rudrapaya, Managing Director, Cordially, Dr. Sita Ramu, President, Fema, and Mr. Mallikarjun, who's the Secretary, Fema. Mr. S.N. Agarwal, who has joined us a few minutes back. He's the Chairman of Baruka. Mr. Ganesh Rao, Vice President, CASIA. Mr. Madhusudan, Regional Director, IGCC. Mr. Sanjeev, Senior Consultant. Mr. Alpesh Mehta, who's the Country Business Head, Siemens. Kiran Mazumdar Shah. Actually, I got mixed up. Kiran Mazumdar is the AVP of Thar AI Limited. Thank you all for all your support. Of course, not to forget you all. Thank you for being here. To everyone here, thank you for showing up with intention, with ideas, and with heart. Together, we are not just reducing emissions, we are rewriting the story of energy for MSMEs. Let's keep the conversations going, the innovations flowing, and the purpose alive. Thank you from all of us to each of you. Thank you.
I think we will, yeah, you want some?
Yeah, I would like to specially welcome KSNG. He has built our CPRI, big sheds, high voltage sheds. So he is a teacher on various traditions, what we are going to follow, what we should follow. And we are going to bother him because he is making liquid oxygen, give us liquid nitrogen that will convert to energy, especially energy storage. Yes, sir. Very nice of you to have come today. Thank you, sir.
With this, I think we'll kickstart the session now. The session agenda is being put up, and I think thank you everyone for joining us. And it's an important session. We look forward to have an engaging conversation with all of you. Thank you.
Make it. ಆನ್ ಐತಿ ಆನ್ ಐತಿ ಹಾಂ ಟಿಪ್ಪನಿ ತೆಗೀರಿ ಎಲ್ಲ ತೆಗೀರಿ ಇದು ಅಲ್ಲಿ ಇಡ್ರಿ. 2 minutes before we start the technical session. Back. Pen around though. Print. ಇನ್ನೊಂದು ಎಲ್ಲಿದೆ? Ladies and gentlemen, we are trying to have a different type of presentation environment. So I'm actually coming in as a introductory speaker, not actually a speaker, but just a steerer, where we move the presentations towards what we intend to achieve. I would take a few minutes. Of course, I'm not putting a time limit here. Idea is, basically, we have a team of energy auditors. We find certain issues that we see on the field. And we give our report saying that these are some of the things that we need to address, or the industry has to comply with. But what has been happening is, although we give the report, there are acceptance, rejections, but end of it, what we intend to do is see that there are 3 levels of satisfactions. One is the management wants that they really achieve some savings on the energy audit that they get it done. And the second part is, whatever recommendations we say, most of the people say, auditors come, they make the remark, they don't even consider whether it is practically feasible or not, and then they just go. Yes, there are equal number of auditors who really mean what they want to say. So in this exercise, what we thought was, instead of submitting a report, we usually do certain follow-ups. We don't just leave it at it. We ask the industry whether it has been achieved or not, if they have got any issues that they would like to discuss with us after the energy audit report has been submitted. And going ahead, if at all they have implemented, have they really achieved the required savings or not? Because ultimately that is where our credibility as energy auditors lies. And the credibility of the entire energy auditor fraternity is established. Because if I have to give a report, and if it is not implemented, or if it is not accepted by the vendor, the industry, then it has a lot of issues that will go. So in that perspective, what we have been doing is trying to change the way of what we want to. And this is one exercise where we discussed with IGCC, because I know Indo-German Chamber of Commerce really mean what they talk, and they talk what they intend to do. Unlike other organizations where you want an event to be organized, they organize and then they just say, okay, done. They collect the photo and then say the event has been organized. But this is one session where, one organization where I thought Indo-German Chamber of Commerce is what is going to be a good platform for forum of energy managers and auditors to launch their event with. So in that perspective, in that view, I thought, let's have this. And although we had too many bottlenecks, you can say, because we didn't have much time. We thought of this event being organized way back in February, but it didn't happen. And later on, it got postponed. And finally, we thought, let's call it a day and then make it in the first event in the month of April. And that's how we finalized. And like I said, we never knew that we are going to be sitting here on this auspicious day, the Earth's Day. Like I had mentioned earlier, there are multiple number of technical sessions. What we would be doing is, after my initial orientation talk, we have one presentation coming in from Ranjanath Goswami is here. It is achieving energy efficiency results using smart and simple IoT solutions. That would be made available to us from Mr. Rajendranath. Then we have energy management and specific energy consumption analysis by Mr. Kiran Muzumdar, who are basically having good number of energy monitoring systems, and they would be making their presentations there. Later on, it is sustainability through high efficiency, low voltage motors, Siemens commitment towards IT, towards it, okay. So this will be taken over by Mr. Alpesh Mehta. And this is one important topic, because whenever we tell an entrepreneur, mostly the MSMEs, because MSMEs doesn't have the kind of resources to say we have an energy manager. MSME doesn't have the kind of skill or the financial resources to have a technically qualified person on their payroll. And as a result, we find many MSMEs being taken for a ride by some of the vendors or say service providers, because they don't have the technical knowledge. They depend on some expert knowledge or expert advice like me or some local vendor or a mestri. But here, most of the time, we find motors. If you look at any industry, there is no exception to this. Motors are the prime drivers. Without motors, I think we cannot proceed even for a minute. If I'm sitting here, and if I have the air conditioning, the AHU working, it has a motor. Be it pumping, be it air handling unit, or be it a process or a manufacturing unit, we have motors. So motors are ones, and whenever a motor fails, it is always a point to blame the vendor, supplier of the motor. We never look back as to why the motor has failed. So our objective, our perspective, or what an energy auditor would like to view is, conduct why the motor has failed. There are certain issues which will give the indication why the motor has failed. If one can look at it, then probably the motor vendor will be, motor supplier or manufacturer will be happy to join hands with all MSMEs to give the right solution. Because not all motors are good enough to be, see, if I said 4-pole motor, not all 4-pole motors are suitable for all applications. There are specific motors, although it is a 4-pole, which basically, whenever a person asks which motor, I want 4-pole motor. So dealers supply you the motor. They don't ask you for what application. Even if they ask, they are not very thorough in supporting you on technical aspects. So as MSMEs, you need to first do why analysis, then decide whether it is the fault of the motor, or it is fault of the driven system, or it is fault of the power supply that is coming in. There are many issues related to that. So wherever we would like to get involved, we would like to chip in and then say, okay, this is the area where we need to touch upon. So kindly, all the requests, my request to all the presenters is not to take that we are trying to interrupt you. We only want you to drive or educate the audience, delegates, so that they understand what actually they feel. Some of the delegates might feel that they may not open up, but on their behalf, what we see on the field, we try to express that, bring it onto the table. Then we have, usually, most of you are already aware of what CBAM is. Am I right, sir? Carbon Border Adjustment Mechanism. Right? No, those of you who are exporting or those who are working with German industries have now got to comply with what is called CBAM, Carbon Border Adjustment Mechanism. Now, if you go deep into the policy, it means every unit of energy or every unit of emission with respect to the component being imported or exported to that component is accounted. So that is where we have Tau.ai, people who would be trying to tell how they were going to meet that requirement of monitoring. And apart from energy monitoring, we also need to, minimize the energy consumption. Minimizing energy consumption not just by process, it's also by minimizing waste or lean technology. So this topic would be taken by Mr. Sanjeev Baitmangalkar. He has been a very senior consultant. He has offered his services to Air India, Boeing, and Toyota. You may say no, but your discussion, because I know him as his junior. Then we have Mr. Rakesh Sai, who would be joining. He is not here right now, he will be there. He would be trying to tell us about indoor air quality and its importance. After that, we have Mr. Navaratan Kataria, who would be talking about digital transformation in MSMEs. Then Mr. Satish Kumar, AEEE. Madhusudan sir? Raghu? Yeah, I think they must be there outside. No, Mr. Satish Kumar is from Alliance of Energy Efficient Economy. So he would be talking about measurement and verification compliance. Now, this is one tricky situation where we always end up into debates. Now, probably some of you, if you are aware of what M&V from Indian perspective is, monitor and verification. All B energy audit, designated consumers are to declare or to get M&V audit done. That is basically monitor and verification. Now, what AEEE does is, or the international standard is, measurement and verification. Usually when, like I said, I gave an example of motor. If I replace the motor, and if I know the energy consumption of a motor, say if it is 100 units per unit of energy, per unit of operation, that is the first round of readings that we take before we initiate any improvement. Later on, after we replace, we also record the energy consumption and say, okay, we have achieved 90 units. Now, on the front face of it, we might say 10 units is what we have achieved. Savings of 10 units is what we have achieved. But verification is 100 units for how many number of components or how many, what is the, at what productivity, and 90 units for what productivity. So that is where specific energy consumption per unit of product is going to come in. So that is what we basically look at, because ultimately rupee per unit is what is more important. Now, in the exercise of doing all this, by improving the energy, by minimizing the energy consumption, we are going to have energy savings. Now, what, apart from this energy audit, what is that we have got to look at? Is energy audit, usually what an energy audit or an audit means, finding audit, basically we all mean that somebody is there to come and find the process. He'll there to do process audit or manufacturing audit and then make some comments. Am I right? Now, the audit from energy perspective is not to find faults or not to simply make remark and go. It's a way to move towards growth. Any comments that an energy auditor makes in the interest of improving the process and minimizing the energy consumption. And in the process, there are so many, too many tangential benefits. Like say, we usually say, whenever we find energy loss, when we do the YY analysis or the background inspection, we find there are some hidden loads, which I call basically as ghost loads. They are not seen to us. Like for example, we all use switch in our home, right? We all use switch. And you all have seen one or the other switch going bad. They must have burnt. Is there anyone who has not seen a burnt switch in our home? We have all seen that, right? Now, burning of a switch is in itself a ghost load. It burns, before it burns out, it will have consumed good amount of electrical energy, which we will not know. We will know only when it is totally blown out. So there are certain number of good amount of ghost loads that we see in all the industries. And of course, there are many topics that we would like, which we can always talk about. But energy audit will improve the efficiency by minimizing energy consumption. Energy audit will improve the productivity. Energy audit will address all the failures that you would not have seen in the future. Or assets going bad or going dead over the period of time. Energy auditor will always forecast. A skilled energy auditor will always forecast this product is going to fail after 10 days or 1 month or 10 months. Because the analysis that has been done, or you call signature analysis that we usually assess, the growth or the behavioral pattern change will tell us how soon the unit is going to fail. Whether it has to be addressed in immediate terms or it can be delayed. So these are some of the tangential benefits that we always have. And with this particular thing, usually when we call the next speaker or the next presenter, I have placed here the whiteboard marker, and we would make some comments on certain issues, and I would request each one of you to just express your views as to where you are coming or where you have an issue with respect to energy consumption. Right, sir? So I think that would make a good beginning, and after that, the real service provider or the vendor would be making his presentation. Now, when we, like I said in the opening session, you are open to go through your PPT, but at the same time, please make sure you touch those topics which have been raised by the MSMEs. So I think with this, I think we would start with the second session, Achieving Energy Efficiency Results Using Smart and Simple AIoT Solutions by Mr. Rajendra Nath Goswami. Mr. Rajendra Nath? Raghu? You're here, no? Huh? Collar mic. Sorry, collar mic. Pocket mic. Sir, how many of you are from MSMEs? Okay. Now, what challenges do you face in complying to AIoT? Aishwarya? Hand mic. Sir? Slide changes. Yeah, right. You can give it. You can take this. I hope. Yeah. So what challenges do we face during in implementation of AIoT?
I'll connect.
Aishwarya?
Switch it if you want.
Mic. Hand mic.
It's right there on the call at the end.
Pratibha?
Oh, you have to connect it there. Then we should go there and
Yes.
I'll do it for you.
Sir, any one of the. Sir? Anyone would like to? I'll go to my. Sir, can you just say why, what inhibits you or what draws you back from implementing AIoT?
Doesn't this have audio? Can you connect it?
So what do you manufacture?
Actually, we are for UPS and all the listen, power solution. My one more person is to come. They are waiting for him, sir.
Okay.
Yeah.
Sir, can you brief what actually you manufacture?
No, I don't manufacture. We have a cloud-based software platform.
You provide service for AIoT.
Yes.
Is there anybody who is manufacturing or into MSMEs? Yeah, please.
I'm Sridhar Babu. So we manufacture precision components and cutting tools.
Precision components for automobile sector?
Yeah, machine tools and
Okay.
mainly machine tools and engineering.
Sir, do you, okay, in the process of manufacturing automobile components, do you subject the product under heat treatment,
Yeah,
okay?
it's outsourced.
It's outsourced.
Yeah, not
Okay, then
in-house.
how do you keep track of the quality compliance?
Yeah, we have a hardness tester, we check it in-house.
No, but how about the rejection level?
No, heat treatment, not much of rejection. It's a
Sir?
process oriented.
Ah.
Usually it is streamlined everything.
No, tentatively, what would be the success level? I would say success level.
Not much, sir. No. Mostly maybe 99.5% everything will be okay. Very rarely this heat treatment's problem comes.
Okay.
Rarely.
Okay, then what other, do you have any rejection in or some issues with respect to automating your automobile component manufacturing setup?
Automation you are talking or what?
Yeah,
sir?
yeah, with respect to automation.
Right now we have CNC machines. It almost does, but automation we are not gone into. But small automation we have made in one conventional machine. We have made automation in Delhi operation. But as a major automation we are not gone because we have a small batch productions.
Okay, now, the basic, you use aluminum, you manufacture aluminum
Yeah, all
components
kind
or-
of materials we use, sir. Aluminum, brass,
Okay,
bronze, steel, stainless steel.
and is it
Polymer.
by casting or turning?
No, it's draw material, steel bars,
Okay.
flats, sheets, something like that. Castings, few, yes,
Few castings.
Few.
So in that, you must be facing some issues with respect to melt loss. When
Pardon?
you cast a component,
Huh.
there will be some material loss in while you melt.
Yeah, we don't have the casting in those.
Okay.
We get it done from outside,
Oh,
outsourced.
that also is outsourced.
Yeah, that is also outsourced.
Okay.
What's his good?
So, okay, sir, since, is there anybody else, any other MSMEs? So, 1 minute. Yes, sir. Huh.
I am able to do that any dimension of that, suppose that lamp, brass lamp, brass lamp, like that, bigger one and longer one. I am able to do the pattern work also. Then
Sir, use the mics.
pattern work also. Then the castings. If you give any dimension is a different dimension, different type of dimension, different type of the longer one, height and weight, different type of castings. Okay, I am able to do that. Previously, I worked in engineering college. I am a laboratory instructor, BE, MTech person. They come and learn in my 1980. I am worked in Gausha College of Engineering, 1980.
Yes, sir.
After 1987, in Saram Vishwesvaraya Institute of Technology. Then, while working only in the engineering college laboratory setting work also I did. The high witness is the Mr. Professor Channabaswaraju, is the head of the department in RR Engineering College.
Okay.
He is my colleague.
Okay.
A lot of work I did casting, sir. In Kashi, member also I am.
Yeah. Sir, with respect to
If you
casting-
give any items, casting, I am able to do that.
Sir, with respect to casting part, you must have, I think I'll just set the thing. You will be working on the costing part, costing per component of the cast that you buy. So suppliers. So you have, when he supplies you the casting, he would have added certain amount of rejections. That he will be adding. That he will be adding.
That will be in the costing it will come.
Okay. Now, sir, in that case, you right now do not have control over the loss incurred by the vendor, your vendor, right? But through automation, can you think it can be made?
Yeah, maybe, sir. We are not aware of that.
Okay, sir. Now, since we have only one input, sir, can you just touch upon this part?
Yeah, and
Please.
I love to come to that. Yeah. First of all, good afternoon to all of you, ladies and gentlemen. Thanks for being here. And of course, thanks to IGCC for giving me this opportunity to share about what we are doing in Bosch. The topic I've chosen is a little bit about trying to understand the way we are able to solve many of the earlier problems in a different way. Yeah. So I've chosen the topic for today about energy efficiency. I believe this is all about energy efficiency. So energy efficiency using a little bit of tech, yeah, tech which is already been used for long enough, and it's all about packaging and using it in the right way. So I'm going to start with the whole concept of sustainability. I think the sustainability in manufacturing has become something which was earlier more regulatory, but meanwhile it is beginning to have impact in terms of it, in fact, even in terms of business outcomes, right? So for me, the way we see sustainability, and I'm sure that that is as much as for you applicable, would be how it impacts your top line and the bottom line, right? Today, there are customers whom we work with, and I'm sure you do too, who make it a prerequisite in terms of fulfillment of regulatory requirements as well as what we are doing towards the future. I think these are very common aspects now covered by the board of every company. And also, in some cases, the purchase insists on some of these aspects being fulfilled, and you may have to also show documentary evidence. So that's one aspect of sustainability. In terms of business sustenance, the other part is, of course, the regulatory part. I don't even need to highlight this. I'm sure you're all familiar with this. And last but not the least, I was referring to the market demands that certain customers, certain regions expect you to be compliant or have a clear roadmap in terms of sustainability. Now, why am I talking about sustainability? While you are working on sustainability by need or by desire, yeah, I think there is a certain cost element to that. Typically, sustainability is considered, a cost factor for that. Yeah. So, in doing so, what I want to talk about today, and in terms of what we have done in Bosch, and I'm sure you can replicate that as much, is not just about sustainability. It's not just about decarbonizing. It's how can we do that while we save money, while we improve our bottom line. How can we improve our profitability also at the same time, right? So look at the key levers in terms of sustainable manufacturing. Broadly, there are two. There could be more, but two major ones: machine productivity and energy efficiency, right? Now, in machine productivity, there's a lot of effort, lot of studies, lot of actions have been ongoing. This is nothing new. We have been focusing on improvement of productivity in every different range of machines. I think Sir was talking about different kinds of molding machine, or even, let's say, different kinds of, spot welding or milling machine or turning activities. A lot of effort, a lot of measures have been taken already. Whereas on the other part of energy efficiency, I think this is something I want to focus on, to share with you exactly what we have done and what kind of results we have achieved so far. Yeah. So when we talk about, we'll understand that we also always look ourselves in terms of benchmark across the globe, right? So it's not just what we call MSME or SME here in India, in Germany called Mittelstand Firmen. Yeah. So I think they are some of the largest contributory part in terms of overall growth, overall productivity, and overall manufacturing outcomes. So here are some references for you. I don't need to get into the details. I just thought I should bring this along, because these often become the benchmark as well as the motivation for us to work towards that. Yeah. So this is a little bit on the Germany, Korea, and also on the China side of it. Even for India, I think BE publishes this information for us, and I have stated that already. It's somewhere between 25 and 40%. Yeah, is already stated, and this is available in their website. So if you have to improve on that, right, how do you work on this? I think Energy efficiency, first and foremost, I think we all agree that unless you start measuring it, there is no transparency on what is happening there. And once you start measuring it, and if you as a leader include it in your reporting mechanism, then you really start seeing the real measures, because a lot of actions can be undertaken. Question is which actually creates the right impact. Yeah. So, and sometimes we are marred with the complexity of actually setting up a system which can effectively measure and monitor this for you, give the transparent data basis which you can actually create the right action for improvement. And in some cases also, you really don't have to, because within your organization, you can create a gamification in terms of what are the measures taken by the different teams, different units, different regional units in improving their energy monitoring, right? So what we have done is we look at three major aspects. One, of course, I was talking about the sustainability part in terms of carbon emissions on your facilities operations. I think this is one part of the overall energy savings and monitoring. Second one, of course, is in the productivity for your manufacturing. Yeah. When I refer to manufacturing, of course, you have to acknowledge, I have to acknowledge that I'm referring more to discrete here. Yeah. To some extent, it can be also done in a process, but in process, it will come to the process cycle time. And of course, last but not the least, the asset performance monitoring. So we use a product called Phantom Edge. Yeah. This Phantom Edge, pretty straightforward to use. Yeah. It's a very elegantly designed aspect. The three most important value propositions for such a product, the way we have using it, it just takes somewhere between 30 and 60 minutes to get this completely hooked up. Yeah. And in less than 7 days, especially in a facilities monitoring part, you have more or less mapped 75% of all your assets. So what it does is uses a unique way of measuring where we read the digital signatures of every equipment. Every equipment can be classified as a resistive load, inductive load, or a capacitive load, or a combination of all of them. It's all about the physics behind how energy is consumed, which we use to monitor the performance of an asset or a performance of a facility. Yeah. So we can hook it up on the distribution box, even at the machine level. Yeah. And then the rest is a simple combination of using little bit of artificial intelligence. I don't want to get you worried. It's pretty straightforward, simple, already plugged in. It learns by itself. So you don't really have to get into the math of how to do this. Pretty straightforward to use, but very effective way of using it. The other part is what you hear about sensors connected and through a gateway and pushing information. What we also use some terminology called IoT. Again, nothing to be scared about. Pretty simple, straightforward to use. So combining the Internet of Things concept of sensors interfacing with the gateway and all this data getting collated in one central location. And in manufacturing, mostly we do it on-prem and avoid it on the cloud for security reasons. Yeah. So we do it on-prem. And this, over time, is exactly what brings the difference. On an individual time slice, this may not be looking like a great topic, but when you have collected this data over 6 months, over 12 months, then you start understanding exactly the profile of your machines, the profile of your facilities, energy consumptions, energy usage, energy wastage, downtime, idle time, energy per piece of product. Eventually that goes into the cost of the product. It's not just the material, it's also the process energies part. All of this data starts showing up in great level of detail, in the level of detail that you want, not overwhelming you with detail. Yeah? So all this comes together, and once you have the data, you have the power in your hands to do whatever you want to do it. Either you can put it in the cupboard and wait for something to happen, but I'm sure as a proactive leader, as a responsible owner of your business, I'm sure you can do a lot more with that. And this is the same data which helps you across all these three topics, whether it is about tracking carbon emissions, improving through energy efficiency, productivity measurements, improvements, as well as asset performance. Because when it comes to asset performance, it is the same level, same data which will tell you the health of your asset. Yeah, whether it is a HVAC, whether it is a compressor, whether it is a machine, this same data actually starts telling you the health. It's like you're measuring your ECG or your pulse, or for that matter, any of your health parameters. You're exactly monitoring the health parameters of your facilities, of your machines. Yeah? And I'm sure you would have done, to large extent, some of these experiments, or maybe you have fully deployed it also. So congratulations on that. At the same time, I wanted to share exactly how we are doing in Bosch and what kind of results we are getting. Yeah. So, yeah, it also depends on the layout. It's not just, so here is a, yep, I think. Well, I leave it to figuring it out how that thing works. But yeah, so basically you have the electrical layout. It's just only mapping to the electrical layout. And you have the different sources of energy and the consumers of energy. And with that, you're more or less ready to get started. So not much of complexity here, but helps you get to very closely to the results. Yeah? If you look at productivity measurements, I want to just share with a few examples on this. So one, of course, is it gives you are done with manual data collection. Okay, manual data collection is prone to a lot of errors, yeah, prone to delay, prone to loss of data, unauditable data. So I think you know the challenges. And in terms of at an enterprise level, the complexity is significant. So what we do is once you plug in this device, is giving you all the different key parameters, especially from your manufacturing domain, right? In terms of machine availability, runtime, idle time, number of parts produced, energy output, energy consumed, and even sum total. So leakages, including many cases where you have found out how the electrical network was placed, and what are the faults in the system, what are the leakages in the system. All of this and more can be detected very easily and very simply using such a solution. At Bosch, we use this extensively for our assets, but also in our machine. So this is, for us, at least I see this as a first starting point in your journey for if you want to go for a full-scale automation in the next steps, right? I'm not talking Industry 4.0. I think that's a little bit too heavy. Yeah, I think, but nevertheless, there are certain elements of Industry 4.0 that you may like to adopt, and this is one good starting point. Here are some, we have done a lot of deployments of this, not necessarily only with us, but once it is proven with us, we have done with others. Yeah, I've listed out a few different sectors: auto, plastics, dairy, and springs, basically manufacturing. And here are some results, insights to motivate you. Yeah, so it is not just us saying that we did this and we got results, but it is also shared results, yeah, collective results in terms of what kind of benefits and what are the insights that we have. I hope you are able to see from the side, or maybe the TV should giving you some picture. Yeah, because there's a whiteboard here, not sure whether, yeah. Maybe you can take it off if you want to. Yeah, so I say this because the insights and the benefits are on the side where you should be able to read that. The rest of it is, of course. This is another implementation in a different domain for a different kind of application. And each of the applications are unique, right? In terms of the machine flow, workflows, in cycle time. So all of this is different. So we have plotted all of this in detail, and that's how we have understood what kind of benefits it can bring. So these are a few case studies. Here in terms of, let's say, this is from the dairy industry, so process flow part where we looked at how much the idle time and what is the breakup of the idle time. All these details are coming out very quickly. There are also other solutions how we can do that. I'm not saying that this is the only way to do that. Yeah, maybe some of you have already deployed it, so you know how this works. For us, this has been a major impact in our own operations as well as in some partner operations. Yeah. The setup is pretty straightforward. I think we use current transformers, so it's a non-intrusive system. So no no intervention with your existing network. Yeah, whether be it for your infrastructure or for your machines, they are basically non-intrusive in nature and keeps the whole process very simple in terms of installation and removals. Yeah. I wanted to bring this along because I'm sure this might be relevant for you. So you might have a question like, okay, which kind of machines is this relevant for? So these are the machines at least which you have tried out, yeah, and we have validated that this works. Of course, the scope could be many. Not everything could be done because in some cases, because of the nature in how we do the soft sensing, right? The accuracy of it may not be proven. So I don't want to claim that this is universal, but at least for these following machine types, we are able to give you very accurate results. At the end, I think we are looking at how to use technology to make simpler ways of monitoring, measuring, and looking for outcomes. So basically, it's important that we do results. Yeah, look at different. There are many options. What gives you to the right results? Yeah. Because for you, I think cost savings are very important. Yeah, and hence to look at the usage and its benefits. So not every case. Last but not the least, I think I'd like to also say that the same device eventually talks about the health of your asset, yeah, and hence becomes very relevant in asset manufacturing case. Here is a machine on which we have plugged up this, but when we do this, it's not just this machine alone, our product alone, but it also combines with PLCs and is able to collect a variety of data, and eventually it gives you the level of information with which you almost are very close to creating a digital twin for your machine. So it's not just limiting itself to certain parameters, but limiting itself to generating a set of data, which is also taking you close to maybe where you want to define your next level of monitoring and simulations. Yeah. So when we talk about PLC, of course, it also means that we integrate with very market available PLCs. It's not that something which is unique. We just use the existing PLCs, not to replace, as long as it has all the right interfaces and the protocols are already available, and mostly that is the case. We are just able to interface with that and take it forward. So it's just an extension to existing systems. Yeah. So when you talk about asset performance, it's not just machining. It's not just manufacturing. There are also other assets, also other segments where this is relevant. So this is the case from cold storage in the food preservation side or in the retail side, where we have these applications also used. Yeah, these are very easy to use, and we do it using at the end of the day, when you talk about IoT, it collects data. When you talk about AI, you are using machine learning, and you are learning over time. And like I was telling you about your personal health parameter, this is almost like a machine health parameter. You see the level of data that it collects, and on the basis of that, you are able to find out what's working out and what's not working out. Yeah. So it's not just for this is an example from the industrial segment. Yeah. So it's also can be used for compressors, airflow, HVACs, and all of that. Yeah. So that was something as an example I brought here for you, which should be simple to use, yeah, should be delivering you results which are important for you, and an example which we have used in Bosch and also worked with few of our partner organizations. Thank you very much. I'm happy to take any questions right now. Questions? Yeah. Yeah, so initially we did start with our own, on our own, for our own usage as a part of our Industry 4.0 journey. Thereafter, we have packaged it out into a small part of the complete solution, which is very easy to use, and focusing on what kind of results. So it's actually available in the market today. So this is more a product which has come from the lot of software technology side. So it is from one of the units in India called Bosch Global Software Technologies. Yeah. Yeah, Phantom is a product, is our product. It's a Bosch product itself.
Okay.
So that's a product which we deliver.
Oh,
So
great.
when you buy the solution, it's basically a combination of the box, which is a soft sensor, includes a soft sensor, not where you have to install anything new.
Okay.
And combined with that, there is what we call the software as a service. So it's basically a portal where you get all the data together.
How competitive and how it's efficient compared to a lot of products available in the market like Econ, Schneider Electric coming up with its own data monitoring and all.
Yeah.
What is the special advantage of this Bosch? Most of the clients are from MSME here.
Yeah.
Is it affordable to them?
Yes, it's very much affordable to them. That's how it is designed. It's designed in India, manufactured in India, but sold worldwide. So it's not limited to only in India. We have sold in Latin America, in South America, in Germany, or in European region. How is it different? I think there are many such products. But when you use it over time, you will understand the reliability and the stability of our product. I don't say that this is the only product. Schneider had invested in a company called Sense in the US. Now they have hived it off. So there are other products also. If you go for anything specific in the market, there will be competition. And I like competition because that's when you understand how it differentiates and you continuously improve your product to stay ahead of competition.
Nice then. And I have seen that you are also doing the legacy machines you are interfacing with
Yes.
this Phantom technology. Do you face any challenge in getting data from a legacy machine, something like a conventional lathe or conventional machine where capturing the data and putting into the cloud software and collecting the meaningful information out of this?
Yeah, so we have done a lot more in the legacy because there is a huge installed base. And that's very important to ensure that we address the legacy machines. So in the legacy machines, the one challenge we get is in terms of the electrical networking and the noise that comes up, right? So that is something that sometimes need to be addressed, but I don't think that's a major cost impact if you were to modify a part of the wiring, because if the wiring is not properly done, because so far it was only about getting the machine started and stopping the machine. But when you want to sense the wire, when you want to tap the wires, for some signals, you may start getting too much noise. If you get too much noise in the signal, then you cannot really process that. So that's for sure a challenge. But otherwise, once that part is addressed, there is no other challenge which we have to address. Second part, of course, is on-prem versus cloud. But we very well understand in manufacturing that it is on-prem. So our basic assumption is it's going to be an on-prem installation. So no discussions about cloud because safety, security, latency are important.
Really nice. Thank you.
Thank you. Yes, please. Yes, sir. So that depends on the type of the machine. If you choose an array of similar, basically I'll explain it the same way. If you look at a set of appliances, every appliance has a specific digital signature. If they overlap, then you need to separate them. Yes.
Then can I connect 5 or 6 machines, maybe different type, injection molding or extrusion molding? Single one, different channels you will get this.
If you want to use different channels, then you have to use a PLC. Otherwise, if you use the soft sensing, then you may have to literally have one box per machine.
Yeah. And second question is the Phantom available on rent? For example, an energy auditor, he wants to use it for a month or so. If not Bosch, is it available by somebody who can hire it per week basis or something like that?
A very, very interesting question. Because so far nobody has asked us this question. I will tell you the models which we have today.
Should move in that direction.
No, absolutely. I understand. The world works very flexibly. So what the current models that we have primarily is CapEx for the box, and the rest of the data and the monitoring is on a SaaS subscription model. That's primarily the model which is there. We did have some projects where we did OpEx over a period of time, operational cost part, not in a capex transaction. These are so far the two models. You are the first one, sir, who's saying that can I have a rental model? We don't have it today. Yes, please. Yes, please. The cost of it is something that we can talk about it because it also depends on. No, I will not get into cost discussion here in this forum, but for sure, I think if you are interested, we can look at it. I would like to assure you that it's not. I mean, it's Bosch product, but it's not such a costly item if you assuming so. Thank you, sir.
Yes, I think now it is 4:10. We all need to go for a small cup of tea. Before we move out, can I just, for you people to understand, automation or Internet over things, I have just, can you just play that? Show it. Yeah, this is what we are trying to say. CO2 level outside the hall, outside the hotel, it reads 551 ppm. This is a meter that we have used just few minutes before. The next one. No, third one. Innondu. Okay. Now this is 535 ppm. That is very near to the reception launch. So it is almost acceptable level. But here in this particular hall, few minutes before, can you show the other one? 13? Murnedu. Yeah, now we are sitting here with 1370 ppm, which means we are not in a safe zone. If there were to be any medical officer here, he would say we are not in a safe zone. And interestingly, temperature here is 26.9. If you consider the temperature, yes, we are comfortable. But if you look at the CO2 level, we are certainly not in a safe zone. Sir. Now, these are some of the issues which we would be addressing with respect to indoor air quality. Now, the reason why I showed you this is, you can see this live here, and maybe after an hour or so, I would be showing you this again, so that the importance, like say automation now comes in here. If we had a system which would monitor CO2 level, and so is the case with respect to humidity, then there could be a regulatory system which can take in fresh air, pump in, so that our CO2 level is always retained less than 800 ppm. And this invariably is also applicable. See, most of the MSMEs, wherever we are going, we also have some hydrocarbons, maybe some solvents. Usually when you walk in, we feel that sticky nature. That could be because of some of the emissions. I mean the evaporative nature where people don't feel comfortable. So you are forced to go out. Not that people want to spend time, they would like to go out because the biological requirement makes them to go out and then take a fresh breath and come back. So now we all can go out, have a cup of tea, and then come back to see how effective. Sir.
This is the problem with all these star hotels.
No, yes.
Because the same air is circulated and there is no planned way of taking fresh air, and the second is the other fumes, like food and other things, gets perspiration.
Yeah. I think I would like to thank Mr. Rajendranath for having given some insight into what new technologies can offer to us. Rajendra sir, thank you. Yeah, we can just come back in 10 minutes time. We are already running late by 30 minutes. ಬರ್ರಿ ಸರ್ ಚೆಕ್ ಕೊಡಿರಿ. ಮ್ಯಾಂಡೇಟ್ ಮಾಡಿದ್ರೆ ಚಲೋ. Yeah.
I'm Rakhi from Devendra, Chennai.
Oh, you come from Chennai?
Yeah, yeah.
Oh,
We are
great.
members of IGCC.
Yes.
So we also export to Europe. So
Oh.
now our customers have started asking for the CBAM.
And you should speak out.
No, but I'm just new. I'm not in the technical side.
Okay.
I've just come to
No, you can
understand.
express.
Yeah. Yeah, but I need to
Understand
We
it.
are new to CBAM. Just come to
Yes, sir. Oh, right. Thank you.
So actually, we also need to understand how you're busy now.
No, I'm not. ಪ್ರತಿಭಾ ಇವ್ರಿಗೆ ಸಂಗಮೇಶ್ಗಳ ನಾನು ವಿಸಿಟಿಂಗ್ ಕಾರ್ಡ್ ತೊಗೊಂಡು ಬಂದು ಕಡೆಗೆ. ಎಸ್.
And we're also trying to understand how to do the calculation for CBAM.
No, that is a big challenge.
Yeah, that's the
Reason, yes, because we do not. Most of the industries don't have the monitoring system.
We're completely into different. I am coming from dynamic staffing here to recruitment. Actually, it was the first event, so I thought let me come in. And office is in Delhi.
Yeah.
Yeah, yeah.
You're from?
Dynamic staffing services.
Oh.
We're into recruitment. So for me, this is new. But I thought, okay, let me just.
Yes, madam.
Yeah. So that's
yes.
the reason I'm here today.
No, certainly we'll understand. Because I'll be touching upon certain issues with respect to CBAM
Okay.
as that things go by.
Okay.
Because I need to accommodate. I curtailed my own presentation because I need to accommodate the others.
Can I have your contact?
Yeah, I'll give you. That's what I sent my daughter.
Oh, she's a daughter.
Yeah, she's my daughter.
Nice. Quite active.
She's working for a company called Fictive here.
Acha, acha.
Same component. I mean, she's also into
Manufacturing.
costing and
Okay.
development.
Okay, okay.
You just have your tea.
Yeah, yeah.
I'll give you my card.
Yeah, sure.
Yes, sir. ಹೇಳಿದೆ ಹಾಂ I'll take, sir. I'll take. Yeah. Bada bhai. I just showed the indoor air quality now.
Shared the indoor quality now.
Indoor air quality readings, whatever I had taken, I just showed it to the people. And I'm listening to stone, Ramesh. Yes, sir. Yeah.
Aqueduct.
Uh-huh.
Interesting what you showed at the end about indoor air quality.
Yeah.
So obviously this
I want to make it as interactive as possible.
Very simple, but I think it's something which needs attention.
Yeah.
We're also in the field of energy conservation, but perhaps on the manufacturing side. We're into, as a service provider for commercial kitchens. So it's demand, no,
Industrial.
like hotel segments and all.
Japanese company.
But even your comments were very appropriate.
For the plants
We exchange cards.
Yeah, 1 second. They want around 14 hours. There is a sensor is there, automatically it senses. Sorry.
1 minute.
Goswami.
ಇಲ್ಲ ಒಳಗೆ ಇದ್ರು ಅವರು ಕೊಟ್ಟು He's inside.
The quality, but our focus is.
That's also important. Domestic sector.
The HVAC consultant here needs to be addressing this problem.
Yes, sir.
So what is that instrument? Where do you find?
It's an indoor air quality meter. There are many companies giving. You can choose one of them.
That's the instrument.
Yeah.
How much is that?
No, that is around 60,000.
We should.
Yes,
So
sir.
anyone can come and monitor in our factory or
Yeah.
area.
There are two instruments. One is that there is one more which will talk only about emissions.
So they'll give a certificate or something like that.
No, see, I'll tell you. Certification is one part. Our intention is to minimize your energy consumption, make, see, indoor air quality. No, the reason is, when you sit in a polluted environment, your work efficiency fails. So we work towards that. See, certification, it can be given today, anytime. But our Indian work culture doesn't really mean.
Why I'm asking that is we are in Pina.
Ah.
In Pina, you know what's happening.
You're from which? You have a car?
My car somehow it's.
Okay. You can, no problem. Which industry?
Engineering industry.
Uh-huh.
Pina second stage. I can.
Yes, sir.
Show my card. You can just take.
No, okay.
You are behind time, man.
How's half an hour? Sir, early morning 2:30 ಬಂದಿದ್ದಿಲ್ಲ ಇನ್ನ ಮಂದಿ. That's why we are rushing through. Slowly, ಅದಕ್ಕೆ ನಾನು ಕಟೇಲ್ ಮಾಡಿದೆ ನಾನು. ನಂದು ಕಟೇಲ್ ಮಾಡಿದೆ ನಾನು. And I'll take the liberty of cutting your time also. ನೀವು ಕೊಟ್ಟಿರೋದು 12 ಸ್ಲೈಡೇನು ಕೊಟ್ಟಿರಲ್ಲ. Okay.
ಸೊ ಅದಕ್ಕೆ ನಮ್ದು ಹೆಂಗಾಗ್ಬಿಟ್ಟಿದೆ ಅಂದರೆ ಪೀಣ್ಯ ಬಂದಿದ್ದೀರ
ಬಂದೇನೆ.
ಪೀಣ್ಯದಲ್ಲಿ ಏನಾಗ್ಬಿಟ್ಟಿದೆ ಅಂದರೆ ದ ಬಿಗ್ಗೆಸ್ಟ್ ಪ್ರಾಬ್ಲಮ್ ಇಸ್ ದ ವೇಸ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್. ವೇಸ್ಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಎಲ್ಲ ಸುಟ್ಬಿಡ್ತಾರೆ. ಪ್ಲಾಸ್ಟಿಕ್ಕು ಗೀಸ್ಟಿಕ್ಕು ಕಸ ಗಿಸ ಎಲ್ಲ ಸುಡ್ತಾರೆ. ಏನಕ್ಕೆ ಅಂದರೆ ನೋ ಕಲೆಕ್ಟರ್ಸ್. BBMP ಅವ್ರು ಬರೋಲ್ಲ. ಈ ಕಡೆ ಯಾರು ಬಂದು ತೊಗೊಳೋಲ್ಲ. ಪ್ರೈವೇಟಲ್ಲಿ ಕೊಡಬೇಕು. ವಿ ಆರ್ ರೆಡಿ ಟು ಪೇ 100, 200, 300, 400. ಪೀಪಲ್ ಡೋಂಟ್ ಕಮೆಂಟ್. ನೀವು ಯಾವ ಡಿಪಾರ್ಟ್ಮೆಂಟ್?
He is a senior consultant. He is going to be making some presentation on waste management. Okay. But not actually waste management.
This Niveda, she uses waste plastic to manufacture.
Yeah, it is there, but it's not door collection. Somewhere they take it from BBMP somewhere, not in the door collection. BBMP door collection illa. Adu ಏನು ಮಾಡ್ತಾರೆ ಸುಟ್ಬಿಡ್ತಾರೆ. So you have to see the monitor that with that machine, what's happening in Pina.
Yeah.
Not only Pina. ನಾನು ಮೊನ್ನೆ ಮಡಿಕೇರಿಗೆ ಹೋಗಿದ್ದೆ, ಮಂಗಳೂರಿಗೆ ಹೋಗಿದ್ದೆ. ಎನಿವೇರ್ ಯು ಸಿ ವೇಸ್ಟ್ ಇಸ್ ಬಿನ್.
ಅಲ್ಲ ಅದೇ ನಮ್ಮಲ್ಲಿ ನಾವು ಮಾತಾಡ್ತೀವಿ.
ಗೊತ್ತಿರತ್ತೆ ಅದರ ಕಾನ್ಸಿಕ್ವೆನ್ಸ್.
ನಡೆದಿದೆ ಇನ್ನು. ಸ್ಟಿಲ್ ಕಾರ್ಡ್ಸ್ ಆರ್ ದೇ ಆರ್ ಮೆನಿ ಮೋರ್ ಕಮ್. ಬಂದಿಲ್ಲ ಅವರು.
Whatever is there, they pulled it together. You have pulled it really well.
Number has to go. ನಂಗೊಂದು ರೂಪಾಯಿ ಲಪ್ಪಿ ಇಲ್ಲ ಚಿಪ್ಸ್ ಹಾಂ ಇಲ್ಲ ಇಲ್ಲ ಬಾ. ಇವರು ಪ್ರಕಾಶ್ ಮಗಲ್ ಅಂತ ಅವ್ರ
I think IGCC only. Taj Hotel. ಅಲ್ಲಿ ನೋಡಿದೆ ಇಲ್ಲ. ಕೆಚಪ್ ಬೇಕಲ್ಲ? ಕೆಚಪ್. ಕೆಚಪ್. ಎಲ್ಲ ನೋಡ್ದೇನೆ ಇದು.
ಇಲ್ಲ MSP ನಡೆದೈತದು. ನಮ್ಮ ಆಡಿಟ್ ನಡೆದವು. ಇಯರಿಂಗ್ ನಡೆದವು ಐತಿ. ಅದು ನೀವು ಸ್ವಲ್ಪ ಮಧುಸೂದನ್ ಅವ್ರಿಗೆ ಫಾಲೋಅಪ್ ಮಾಡಬೇಕು. ಏನಾಗುತ್ತೆ ನಾನಾಗಲಿ ಮಾಡಾಕತ್ತಿದ್ರೆ ನೆಗೆಟಿವ್ ಕಮೆಂಟ್ ಹೋಗುತ್ತೆ. ಹಾಂ ಅಲ್ಲಿ ಒಳಗೆ ಆಗಲ್ಲ. ಹ್ಞೂ ಅಂಗಡಿ ಇರ್ಕೋ ಕೇಳಿ ಹಿಡಿತಾಳೆ ಕೇಳಿ ಕೊಡಬೇಕು.
ಅಲ್ಲಿ ಇಲ್ಲ ಮುಂದೆ ಐತಿ ಕೊಟ್ಟು ಬಿಡ ಮಮ್ಮಿನ ಕೈ
Yeah, sir.
See, in the particular project, it's Japanese. 1400 was CO2 limit. When it is 900 come only, it's automatic monitoring. So I'm telling, say 5 years back, come back. But if you want to enter that premises, okay, it's little open, we will little open air. Above 450,
Yeah.
looking for you. Above 450, they will not permit.
What?
Above CO2 ppm.
Above?
450.
What?
ppm of CO2 in that road.
Ah.
They will say, no, don't go it. They will not permit. Okay, it will give an alarm when any
Now, how much it should be?
it should be below 700.
Ah.
It should be well below 700. But Japanese standard, they kept it. They are always linking the same, 450. Now you are telling them we have around 1,350. Even some people who have other problems, they can unconscious this level. Okay. No, I'm just telling you the end of this thing.
Unconscious, we will not go to that extent. We will start feeling sweating ಬರುತ್ತೆ ಕೈ ಇದು
Some
ಆಗುತ್ತೆ
people will get a little dizziness or sleep, little old people. We will saying that we have taken curd rice, that is why. Not curd rice, because of this problem. Because of this problem. 1,300
Sir,
or
World Health Standard says up to 800 is okay.
this 800 is okay. They are considering our, African countries. African countries and
Indian,
so many things, they are specification is there. Even for water, drinking water, their specification is there. If you drink, you or me drink that water, you will get tonsillitis. Okay, our condition. Future standards, certain things are like that. Because they have to look on everybody, not you and me or India, anybody. But this especially is Japanese. Okay. Because
Japanese
while
also.
one day the alarm sensor have some problem. Okay. Then it was not sensed. Okay. They have the remote control. They call a sensor. Why it is not? Why it is not?
We are now we are in a chalta hai attitude.
See,
Unless-
you
see.
are here, you measured. Nobody is there. If it is 1,000 or 2,000,
See, unless measurement verification is ಒಳಗೆ, this is what we are trying to tell you. Indoor air quality. Unless you measure, you will not know.
that is why. See, for this is for what is produced for now. Small like this, small ozonator, something like that. Small ozonator. It will be very good. I wouldn't like this.
ಯಾರ್ದು ಹೇಳಿ
ಆನ್ ಐತ್ರಿ ಒಳಗೆ
ಹಾಂ
ಮೈಕ್ ಆನ್ ಐತಿ
Ladies and gentlemen, can you please take your seats? We would like to start the next session. Thank you everyone for joining us again for the next session. And I hope you are all refreshed with some tea and some snacks. So I would like to call Mr. Kiran Majumdar, AVP Tor AI Limited. The next session would be on energy management and specific energy consumption analysis. So I would like to hand it over. Thank you, sir.
Hello. Is it on? Okay. Now, we are now getting into energy monitoring being offered by Tor.ai. Basically, incidentally, we have one delegate who has come all the way from Chennai. I think I'll use her inputs to relate this particular discussion that's coming up. Madam was talking about CBAM, where they are now they need to comply to CBAM regulations. Okay, now, can you share the mic? Mic. No, since she has to comply to CBAM, the challenges there are, can they consider all the energy that has been consumed to declare as their emissions, or address it specifically to the component that is being manufactured, that is being exported? Samir, Mike, yeah. So can you just tell the audience what actually you have problem with?
Hi, hello. I'm Rakhi from Devendra Autocom, Chennai, and we are into manufacture of critical engine components since 1965, and we have been focusing on the automotive and the defense sector. So since we are into exports as well, as per the European Union, we need to comply with the CBAM. So I've just come here to understand how do we go about following the CBAM rules. Although internally we have been doing it already, since we have to share the details to our customer. So that's the reason I'm here to understand from IGCC as to how to go about complying with the CBAM standards.
Okay, now when that is a challenge, I think for you people is bit, you are comfortable or you would like to shift this side? Check if you could. Okay. Now your choice. Now CBAM basically, like I said, carbon border adjustment mechanism. What? No? No, carbon border adjustment mechanism, by it, the very word, it tells you carbon emissions. Border is very movement I cross from one premises to the other premises. What is the impact? And how do I make adjustments to the emissions that I have inherited in the course of manufacturing my component. That is a mechanism, simple terms. Now, like you said, in all the cases, the worst or the least importance that has been given is monitoring. Many of us do not have monitoring at a root level. How many of us have energy monitoring meters? One is the main, which comes from utility. Any sub-meters that we have? Any sub-meters? You are having that awareness. Yes. By monitoring, you are creating an awareness, or you are making inmates understand that these are the load centers.
So there are different ways to conserve energy. So we have a clubhouse also. So I have installed 1 meter on clubhouse feeder and given the responsibility of optimizing energy to club in charge. Okay. So he was being questioned after every month that your consumption has gone up. From that day, he has become more vigilant on how many ACs are required. Some ACs he will put off. So having monitoring mechanism definitely gives you a guide towards energy conservation.
If I assume that you have 100 components being manufactured in your plant, out of this, how many do you export? How much? 50%. Okay. Now, yeah, that's why I said I use the figure 100%.
Yes.
Now, out of this, 50% are being exported and 50% are in-house.
Yeah.
Right? Okay. Now, if assume that you are consuming 100 units of electrical power or energy input, either electrical, thermal, or in whatever sense, if you are consuming 100 units. Now, if you do not have the root level monitoring system, you will not be able to define how much of energy you are consuming with respect to the product that you are exporting.
Yeah. So there are in certain cases we are getting, say for example, the raw materials from outside, and only assembly is being done in our setup. So in that case, where right from the scratch to the finished product, it's not being done under our roof, how do we calculate?
Yeah, that's what
Yes.
See, you do not have right now any data with respect to how much of
we
energy you are consuming with
no,
respect
we
to...
do have data.
But?
In case where we have the raw material or some partly finished product from outside and the final assembly is done at our side.
Okay.
So in that case, how do we...
No, that's what I'm saying.
Yes.
What activities you do within your plant, within your establishment?
Okay.
Do you have energy data for that?
Yes, we do have.
You do have?
Yes.
For all the components individually?
Yes.
Huh?
Yes.
So how many meters you have them?
Okay, that part I'll have to check my technical
Approximately
person.
you have.
I'm really not sure on that. I shouldn't be giving any wrong figure.
Okay,
Yeah.
so now if you have monitored energy consumption for each of the components,
Okay.
right? Now I'll go further. If this is say around in terms of weightage, out of 100
Yeah.
kg,
Yes.
I will say some of them are 10, 8, 5 kg.
Yeah.
Okay. Now, the rest can be, say, around 9, 7, 3 kg domestic consumption.
Yeah.
So, when this is a scenario,
Yeah.
do you have a mechanism to say this particular component which is weighing 10 kg
Yeah.
is consuming so much of energy?
Yes, we do have that.
You do have that also?
Yes, yes.
Then how about 9, 7, 3?
I'm not sure on that, yes.
8 and 5?
Yes.
You have for what you are exporting?
No, in case whatever work is being done under our roof, we have the details. When we are getting it from the supplier or
Okay.
from the vendor.
What do you do under your roof?
I need to
Assembly?
check. Yes, we do assembly.
Only assembly?
And machining.
Machining also?
Yes.
So every machine is having an energy meter?
Yeah.
Okay?
Yes.
So, okay, now because you have a meter for every machine,
Yes.
where you carry out the process,
Yeah.
you are able to define so many number of units for so many number of jobs
Yes.
that have been conducted.
Yes.
Right?
Yeah.
No, that is the reason why you are saying, okay, I have data for 10
Yes.
units or 9, 8 or 5 or 9.
Yeah, yeah, yeah.
Now, this makes your task simpler
Yes.
because out of the 100 components that we are manufacturing,
Yeah.
using the energy data, you can define how much of energy you are consuming specifically for this component.
Yes.
Now, if you are exporting this component in various numbers, out of the 50%, assume that you are exporting, say, around 20 numbers.
Yeah.
Now, you will be able to define energy consumption for these 20 numbers.
Yes.
Now, total energy consumed by you for the 100 components that are there will not apply to this 10 grams.
Yeah.
Whatever energy that you are consuming with respect to 10 components is what you are going to define as the energy content or the carbon content. Right? Now, energy consumed by what is 50% of the units, which are basically catering to domestic market, will not have any is being done here.
Yeah.
So this is what the CBAM is asking for.
Yeah, yeah.
Okay. Now, you will have to have a clear mechanism.
Yes.
When you say clear mechanism, you have to have records to say these are the things that we have. And once you have records, then it will be very easy for you to say, yes, this is this.
Yeah,
Bought out and subcontracted items, I think, especially which you are exporting, in that, how much of energy has been consumed, what is the carbon footprint there. That, obviously, that information right now you do not have. But what you have, I think, whatever Malik said is correct. I think you can segregate. So I think CBAM, I think you'll have to, questions will be raised on both fronts.
This is what actually would be touched upon by Cordially. They are going to tell us how their system will come to our help. Those of us who do not have the monitoring system, fortunately you have the monitoring system, so you are able to answer. Now those of us who do not have monitoring system, I think Cordially will tell us how it is, and I think Kiran, you can.
Yeah, thank you. So I think
Just one more input, madam. See, as I understand, yours is a machine shop and assembly, correct? So there are different components going through different process, and it will be a batch production. So you will have the same machine used for different components. So what my understanding or input is that you can monitor by seeing the when the process starts. Before you load the first component, you see what is the energy meter reading, and it will say run through about 1,000 parts, assuming. Then end of the 1,000 parts, what is your energy consumption? So how many components you have produced? 1,000. and what is the energy consumption. So you get per component so much of energy. That is one monitoring. The second one is then you can say per gram or per kg of component. Different components will have different weight. So these 1,000 components that you have manufactured may be medium size, say about 50 grams or whatever. So you can break down to that. Say per gram what is the consumption. So this will give you a very good idea. Okay, now coming to what you are getting from outside and just assembling, it is something like a value addition. Okay, you buy at X cost and then you, after assembling, you are selling it X into Y or whatever, 3 times X. So that is the value added for you. That is okay. Similarly, you can say that when you assemble them, what is the energy consumed for assembling. So these parameters will give you a monitoring guidelines. Thank you.
So, yeah, I think let me start. Good afternoon, everyone. So, my name is Kiran, and I represent a company called Cordially. So, Cordially is one of the leading and largest IoT company, industrial IoT company in India. So, whatever we do, all our offering, our solutions, and all with respect to addressing the problems of industry, either it can be MSME or a larger industry or a buildings, hotels, it can be anything. So I think today my topic I'm going to cover in next 15 minutes, the energy management, how do you do that? Then what is the specific SEC, specific energy consumption, and what are the components involved and all those things. So quickly, briefly on our company, the Cordially, it's a 13-year-old company now, and we are a full stack company. So when I say full stack, it's right from having a IoT device, field sensor, assessment, installation, commissioning, and prescribing. We do the end-to-end analysis offerings. So it can be any industry. So next is, as far as products are concerned, we have 3 type of offerings. One with respect to the Torch Shield, which is a kind of a BMS 4.0, or which is predominantly used for utility monitoring. So the second one is the Tor Equip, is all about the equipments monitoring. So where we do the telematics of many equipments. It can be chillers, compressors, generator, as a standalone as an equipment. The last one is the Loco HE. It's all about monitoring the telematics for heavy vehicles, equipment. So it is like a tracking, geofencing, and what are the driver behavior, consumption, and all related to the telematics of the heavy vehicles, fleet management. And our credentials, so far we have deployed around 3 lakhs devices globally, and different sectors. It can be chillers, compressors, genset, and all. And since we are a cloud company, we have all cyber security, all related to the type test reports with respect to the hardware, software, everything is in place. Then those are our customer credentials. IKEA, JSW, even from across all the segment, automotive component manufacturer, hotels, Club Mahindra, and all. And global footprint, we have an office in Dubai. We have a business office in Kenya. Then we work generally with channel partners. So around 140 channel partners spread across India by now. So now move to the topic. So in any energy management system, so energy is just not of the data taking from the electrical meters. So there are many components involved in that. So the typical problem statement in any industry is what in my experience is they say there are many solutions are available at every section. It means somebody will give the ring for utility monitoring, and there is a solar, there is a separate application, there is a genset monitoring separate applications. Like that, there are many. Every company want to promote their product. It's fine. But as an end user, one of the plant manager, he told me that I need to log in, at least open 6 applications every day to take my data, minimum data, all these things. This is the one. And thing is, most of them are the standalone solutions. It can operate in only one computer, or it can be in one server. So they are not can be accessed from anywhere. Datas are not interlinked. Then again, it is by and large, it's more or less doing a manual entry job. Take all the data, put it in an Excel, again put it in a right format, again upload in a ESG format or through the ERP system. So This is the typical problem statement, and there's a hell a lot of licensing is involved. So which license, what renewal, who has to manage? This is all the typical and not able to scale. 5 years back, I have installed something, one application, and today I want to install, do the little bit tweaking on that and some reporting changes. It's all tedious task. Still, that this is one of the critical problem statement where many of the small industries, larger industries are facing. So second is, as we company can monitor able to all these utilities, energy, HVAC, genset, STP, ETP, air quality, busbar trunking system, electrical panels, and air gas stream, APFC panels. So by and large, it covers entire plant or entire building. So why it is important is, one is you can do the consumptions optimized. So once you have the consumption, you can do the benchmarking, you can do the analysis, you can take some decision what I need to do. Next is compliance simplified, and any companies which are going for ISO 50001 or a ESG compliance, or you are doing the exports and you need to have some green initiative compliance, this simple data can help you to mitigate these kind of risk. The third one is the continuity ensured. So once you have above first 2 C's, then it is easy for you to avoid the backdowns and do some prediction on your production plans and further capex investment. So it will help in a many way. So based on our experience, these are all the utilities which are very important with respect to energy or utility monitoring. So when I say energy, again energy is split into 2 parts. So one is the active energy and another is the reactive energy part. So active energy, when I say, you need to, initially as an organization, need to monitor the different sources what you have to your entire industry. So one is the typical sources is the power from the grid, which is anyhow you have from the HT, it will become MV, or sometimes HT to direct to the LT. At least LT main incomer. Then if you have a wind and solar, or a solar plant, or a rooftop solar, then how much you are doing that, generating from that, how much you are using that, and what is the efficiency of the inverters being installed there. The third one is the battery storage, energy storage devices if you have, how efficiently that is working. The third one is the backup generator, how many generators we have in our premises and how long it was on, what are the run hours, how much fuels are burnt, is the efficiency with respect to the fuel to the power generated is correlating or not. So those analytics we can able to do that. The second part is the reactive power management, which most of the time it is the untouched part in any SCADA, any energy management system, anywhere. You need to understand that what is my reactive power demand in my entire system. So how my APFC panel is working. Is the relays are switching in the right way or not? What is the aging of the capacitors bank? Are they really working? Are they really switching? And what is the level of harmonics I have in the system? So those analytics you can get it from the APFC panel monitoring. The third one is the safety and infra, where you have a LT panel monitoring. Among your LT system, you have any one of the panel which is going for the critical loads, where it is kind of a melting, bending, milling, or a furnace or something like that, and it's carrying around 3,000, 4,000 amps of current or 1,000 amps of current. So, and you find it is very critical with respect to the your production process. So there we can monitor all the LT panels, bus bars inside, ambient temperature, outside temperature, electrical parameter of that critical panel. That you need to identify which one in my system it is. The next is the bus bar temperature monitoring. If you have a bus bar in the system, in the building or at a hospital, or it can be any manufacturing facility, or bus bar to cable, cable to bus bar. Generally, it will be a bus bar to the cable joints. So generally, the temperature rise happens at the junctions and the joints of the bus bars. So this can be of 3 reasons. One is aging of the joints, or the corrosion, or if the load itself is drawing a higher current than the size of the bus bar. Or sometimes even cable heating up starts over a side of time because it is because of the aging, and or sometimes it is even because of the excessive load. There are many reasons to that. So this we can able to monitor in the LT and panel. Next is the water level. So water is again untouched part, and soon or after in a year or so, in a few decade, it is going to be one of the important commodity. So may not be the power. We have a sufficient power now in India. So water, what I want to say is, in the water, if you have water as a process if you use the water in a process of your operation, maybe you are a food processing industry, medicines, or you are a hospital or you are a buildings where water is part of that, or if the water is the byproduct of your end product, maybe beverages and all those things, means water is one of the commodity, it is one of the raw material which needs to be monitored and analyzed. So that is there, how we can do is just install the flow meters, what is the main incoming, what are the different sources of water, and is there any bore well, tube well from the tanker or any treated water, so those can be analyzed from here. Then what is the consumption by the section wise, and if you have a STP, ETP, how much water is being treated, how much is used, and what is the energy involved in treating that much of water, and how much you are discharging back to the ground. So all these key analytics will help you that what exactly happening in my system. So this is the kind of, they call it as a granular visibility. Other than this, you have any compressed air, gas flow consumptions, you have any meter, maybe you have a LPG, LNG, nitrogen, or any other gas, and compressors in the system, and you need to monitor that details, even that is possible. So what I mean to say is, so you should have one IoT application where it should cover most of the things and it should be scalable. So, and by and large, these are all our devices which we use, called it as the edge gateways, they are called a bare metal gateways, they are called a protocol converters, there are sensors. So these are all the devices we use for different applications, and we make the system up. And that's the visualization where the cloud, where you can have your complete analytics, it can be accessed from anywhere, from anybody, data is well secured, and it won't need any huge IT infrastructure, you don't have to invest on the licensing, servers, nothing is required, no wiring, and no too much of rework. It is a completely retrofit applications. So this how it is generally the framework of a industrial IoT system happens, and slowly it is evolving, and it is a very cost effective and easy to do that. So that's what I can say. So next is the topic, the specific energy consumption. So this is the one of the important topic when you have the monitoring system, you have monitoring for water, energy, and all the sources. So next, what should I do with that? So this is a very simple mathematical term where specific energy used divided by the amount of parts produced or a particular interval. The math is very simple. So, but when you want to really compute that, it is a very tough and tedious job, because you don't know if I produce in a window, certain window of time, I produce these many number of parts, and how much energy is used for that. So, how much is energy incurred in producing each part? What is the level of water? How much is used to produce those many number of parts? So these analysis you can able to get from the specific energy consumptions. So for example, let us say textile mill, and they are spinning or they are doing some process of operations. In that, they produce certain amount of garments. In that, how many times the DG was switched on, how much they have used the genset to produce that many number of parts. Because the energy used from the DG or a genset or from the EB may not be, the cost may not be the same. It is obviously in the higher side, and obviously that part, delta part, is not accounted in the overall cost of the product. So these will help into analyze all those costing to any companies, manufacturing companies. So why it is important? So as energy wastage you can avoid, equipment process, and it encourages the optimization, and also it is bringing some lean system in the entire industry. It is from top to bottom. Till the operator level, everybody can have access to this, and they come in a order. The next is reduce the cost of the production. Automatically, when you manage, when you monitor specific energy consumption, it will in turn bring in the discipline in the entire organization, and with that it will also help you to lower the cost, and where you can act, where I should really touch upon that, and where energy is leaking or the money is leaking. That's one. Then overall efficiency will be improved in the industry. Then it supports sustainability goals, and tomorrow as an organization want to go to some ESG goals or IoT 50,000, these simple data which you can download and You can give it to anybody, or you can upload to any portals, which will help in a click to comply certain critical ESG and 50001 and these reporting. Then it make you to some capex decision, important decisions, that where do I need to invest, how do I expand, what would be the cost, if I add one more machine, should I shift it to the production slot from the peak hours to the lean hours. So these decisions can operator level they can make. And we have seen the many small industries in and around Bangalore, Pune and Coimbatore, they have achieved tremendous result. Even hospitals, they have achieved a tremendous result just by doing these kind of basic analysis. So when I say this SEC's, Specific Energy Consumption Report, it is different from industry to segment of industry to industry. Steel industry needs something else, kWh per ton. Cement industry needs something else. Textile industry needs kWh per fabric. And food processing industry, they need energy, they need water, they need any other parameters also if they are using as a fuel like natural gas and all. So they need to account all the three. It is just not the electrical energy, it's the heat energy, steam, everything it has to, it will be there. What we do is, so once you have the data, that application is ready to use that data, and it's only a matter of click, you can download any report from anywhere. And you can also have all the bifurcation what is needed there. And there is a back-end AI engine will be running. So which, deciding the patterns. It is nothing more than that. So over a period of time, once you have the data, you can do the patterns of the production. What is my pattern? What is the environmental parameter? What is the machine efficiency? Externally, without doing anything, you can able to derive all those things. So automated reports are already in place, and you can forecast peak hours, lean hours, and suggested load. You can do the load optimization with respect to all the utilities what you have. So benefits of IoT utility, BMS 4.2 are, you can even say monitoring system. So one is, you can easily get into any compliances, 14001 or 5001, and even energy management. Next is tracking of all the flow meter, water meter will be easy. There is no manual errors, there is no interference, and enhanced decision making. Even from the top management to the ground level management team, they can have the visibility on what's exactly happening. And even the operational head can sitting at a one click, he can able to get any report he want. For example, if I want to download the report of how many times the under voltage has happened in last 1 month, so that he can able to get it. Just so. And how many times the overcurrent and simple. And entire, you can see the structure. If I do ESG, then it needs energy, scope 1, scope 2, analysis can be done, grid power, genset power, and all these logs can be monitored there. So it's a matter of click. Similarly, with respect to the water, sustainability goals, and there are many companies who are even going for water neutrality. So they are all using our applications, and they can get these kind of logs, which is very handy to them. So I think that's it from my end. And any questions? Yeah.
Hello. Yeah, my name is Bakkar.
Yeah.
See, this IoT system can be used for PID panels.
Sorry, sir?
PID panels.
Okay. What means?
What PID panels mean? Normally, when there is a variation in pressure, temperature, flow, and everything, it will automatically correct it and operate it.
Yes.
But when you install this, we know what time it is happened. Sometimes you don't want to know the time.
Yeah,
it will set it and correct it and operate it and run the system, process system, run it. But when this IoT is fixed, can we get the details, what time it is happened?
Yeah, that you can get. See, we can set the alerts for any abnormalities or any, for example, after you have a production of pattern, and let us say it is deviated, that alerts you can able to set.
I don't want alert, I want the feedback.
Yes. Feedback can be done.
Feedback you can take it
yes.
from the backup?
Yeah.
How many days it will be there?
No, it will be there in the cloud. The data will be there with us always in the cloud. And see, it's all about the handling data, sir, now. So earlier it was having the application. Now it is all about handling the data. You can have the data, anything. Once you have the backup data from different field sensors and all your system, you can derive anything out of that.
Okay, thank you.
Yeah, please.
Yeah. So hi Kiran, I come from Zeiss.
Yeah.
I mean, a bit different, setup. I'll tell you. So we have around 40 small setups across India, wherein we are trying to capture the electricity consumption. As on date, it is completely manual. We depend on the electricity bills, which comes maybe monthly, in 2 months, 3 months, and it's completely manual. It's not structured. So, do you have a solution for this? That yes, across India, I sit somewhere.
Yes.
And it's,
Yeah. It is very simple and easy to do, and very cost effective also. Nothing much investment is all needed here. It's all about anyhow we are not supposed to touch the meters of DESCOMs or
so that was my
given.
question,
So, but we can do additionally add one more energy meter at a LT side, and we can able to monitor this. And many companies are doing this at the central level. They want to monitor what exactly happening, and this and all we can do it. It's very simple.
Okay. Thank you.
It's all our requirement is very simple. One energy meter and one gateway should be done.
Not very complicated.
No, it's not complicated. Yeah.
This is what we just spoke to you
Yeah.
about process of data collection, data mining, data analysis, and data management. So entire all these four will make your CBAM compliance more simple. I just spoke about 1%, but he spoke to you about energy from electrical, fuel, water, from all. Right? I think, thank you, Kiran.
Thanks.
That's good. So now we have the energy drivers, or the drivers of all the MSMEs. Motors, in the morning I already just touched upon. I think I'll not touch much on this. Sir, if you can kindly, Mr. Alpesh Mehta, he'll just touch upon the motors topic. Sir, if you can kindly elaborate.
Is it so?
Yeah, correct.
No. It is so.
Sir, if you can kindly touch upon selection of motors, slip
Hello.
ring, induction.
Hello. We can touch upon that also, but I have got 30 minutes, and someone said that we should regulate our time used also. I will touch upon, and let this be a first step towards energy conservation, which this journey can start. And then we have got people in Bangalore also, they can come down to your doorstep, so one more forum can be arranged. So good afternoon and namaskara. So topic in front of us, can you please put the first slide on? So topic in front of us is very, very serious. That is global warming. Before I get into the contents, I would like to, everyone knows because people are relevant here, I would like to take the seriousness to the higher level by showing some pictures. Okay. So let's go to the next slide. It's not working. So I will ask some questions to make this session more interesting and engaging. Can you identify what this picture is? Is a land, okay, with a grass on it. I'm sure you are going to identify this picture after a slide or two. Can you identify this picture now? Hello? If those who couldn't identify till now also, now they must be identifying. This used to be a screensaver, right, in our early days. And it has imprinted in our mind. So what is the difference between the first slide and the third slide? First slide was clicked in the 2006, and this slide was clicked on in 1996. So in 10 years' time, we have changed the landscape. It's very important to know the speed with which we are tempering nature, we are hurting nature is very fast. And during this session, Mr. Mallikarjun showed some meter, okay? And he said that beginning it was X level of carbon dioxide, and then it was elevated level of carbon dioxide. What was the cause for this? Why it went up? Because we people are breathing. We are breathing. We inhale oxygen and we exhale carbon dioxide. So good that there were 110 people around. If there were 130 people, level would have gone further up. So let me take you to the basic topics. This is regarding global warming. We hear a lot about net zero, carbon positive, carbon negative, carbon neutral. So let's understand, many of you, most of you would be knowing about it. So nature has a limit, okay? When we said that level has gone up, someone said that hotels should inhale or rather infuse fresh air from outside, and then maybe level can be brought down. Our Mother Earth, where will it get the fresh air from? It has to recirculate. So nature has got limit, and we guys, like we human beings, maybe centuries back, they were like this. Animals, human beings, they were exhaling carbon dioxide, and there were lots of trees, lot of forests were there. They had their huge capability to absorb carbon dioxide. So there's a trade balance, right? Where, the carbon dioxide we were pumping to the nature, and the other cycle which was converting carbon dioxide to oxygen. So this arm was very strong, and that's why nature was quite good. And the picture in the first slide could have been green, okay, if we had not exploited the earth. What happens later on? We have multiplied our count. Human beings, what it was earlier, now today we are close to 7 billion human beings on the earth, and we are trying to be on the top of the table. The population has gone up, so people exhaling carbon dioxide has gone up. Animals also have gone up. And we guys, right, we want comfort, we want vehicle. Vehicle also were added to add to the problem, and we wanted factories also. What all is required, it's required for human beings' comfort. It so happened that the deficit, the carbon dioxide generation, went on higher side compared to the absorption. It is like trade deficit. So we people started depositing carbon dioxide in the atmosphere. And more the carbon dioxide in the atmosphere, higher would be the temperature of the earth. It is said that up to this, the temperature increase. Let me tell you, global community is very closely watching how the temperature is rising. Average temperature rising. So up to this also, the delta temperature was much less than 1.5 degrees Celsius. Then we went further. So why it is not moving? Just click there. Then what happened? We went further. Population went up further, right? We started establishing factories, we started polluting the atmosphere beyond its limit, and then we have gone very close to incremental temperature of 1.5 degrees Celsius. Now, what next? It is said by scientists, it's said by global leaders, if this delta crosses 2 degrees Celsius, it is going to be a death sentence. Whatever temperature was earlier, if that incremental temperature is more than 2 degrees Celsius, it is going to be death sentence for mankind, all creatures on the earth. That's why, if this happens, maybe we will cease existing, and maybe this forest also would come to a very, very low level. So it's a place taken by global leaders that we have to confine this delta rise, temperature rise, within 1.5 degrees Celsius. And that's why we are seeing a lot of commitments made by leaders. So now I'm coming to the contents, sustainability. Sustainability is very important for us. It is more important for our next generation, and it is crucial for generation after. Sustainability has got 13 goals. We can't go to all the goals, 17 goals, sorry. It talks about zero hunger, equality, but in this session, because I represent a low voltage motor business, right, I would like to confine this topic to low voltage motors where it matters more. So here it says, goal number 12 says, responsible consumption of energy or production. We can't say, someone said that we can't have zero emission. So we can't say that we will stop consuming energy. We will need to consume energy for our own comfort and for development also. But at the same time, we need to be responsible enough to, while using energy, we should be responsible enough to conserve it, to save it, to leave it for the next generation. Second important topic is climate action. So we need not have add into hazardous substance to the earth. Now, if you look at this picture, this was in Dubai, COP, where our Honorable Prime Minister attended, and then he said, India will take 35 years, okay, almost 35, 45 years to come to net zero. Means we will need, after so much of concern, so much awareness also, we need so many years to bring balance between carbon dioxide we are emitting and the oxygen and the absorption which is being done by forest. India has taken a pledge to have net zero by 2070. China has taken a pledge to become to net zero by 2050, and some European countries are trying to go even earlier also. There was one country around us, Bhutan, they claim to be carbon negative, right? But I was told that they also have turned to zero, and maybe they also may go to carbon positive because of the development. Something wrong with the system? Just click it. I hope cells are working fine. So we into low voltage motor business, and as some sir said that we are from prime movers, right? So a low voltage motor is a prime mover of the industry. It was said earlier that 70% of electricity consumed in industry is consumed by motors. 70%. This statement is around 15-20 years back. Now, I was reading that one question asked to ChatGPT, it consumes 3 watts. So now the energy guzzlers are, along with motor, data centers also have become the energy guzzlers. Let's leave data center aside, but electric motors are the energy guzzlers. 70%, if not 70, 60% of energy consumed by electricity, by factories is consumed by electric motors. So we have to be very, very concerned about it. So Siemens being a global manufacturer, we are committed to it, and we are doing almost everything to reduce the energy consumption by motors. First, if you look at it, is first of all, high premium efficiency motors. We have to lead the industry, low voltage motor manufacturing, and Siemens has a lot of pride to lead the industry. We produce the motors which are high efficiency motors. Second is true commitment towards high efficiency. Okay. Before I go to that, I think it's some jumbling. Okay, so you stay here now. So this is a very well-known example, okay, and most of you, at least those who are auditors, right, they must be knowing this example. What kind of mind we apply when we buy a motor car? And what kind of mind we apply when we buy 20 HP electric motors? You are maybe owner, you may be having plants also. When you want to buy a car, maybe you would study a lot many things, do some comparison also, and then decide, okay, this car is good. Are we applying that much mind when you buy 20 kilowatt motors or 20 HP motors? Let's see what is the impact of cost of use, right, and the cost of purchase. So one car may be costing 20 lakh rupees. Electric motor, it is said to be one of the most economical prime mover. 20 HP motor may cost somewhere around 50,000 rupees. This car may run for around 1500 hours a month, and maybe these motors, I've taken an example for paper industry, this motor may run for around 600 hours a day. So maybe 18,000 kilometers per year, 7,200 hours per year. If I take cost of running electric motor car is 10 rupees per kilometer, I've taken some figure which is easy to understand, calculate. It may be actually higher or lower. For electric motor, you pay 10 rupees per unit. So to run electric motor car, you are spending 1.8 lakh rupees only. You are investing 20 lakh rupees and you are spending 1.8 lakh rupees only for usage. But for electric motor, you spend just 50,000 rupees. And this device will decide how much energy it will consume. And it can be almost 12 lakh rupees. Does it not mean that when we buy electric motor, we should apply our mind to 30 times more than the mind we apply when we buy electric motor car? Let's have one more example. There is called something motor operating cost as the percentage of life cycle cost. So one is for 1.5 kilowatt, then 15 kilowatt, 110 kilowatt. Let me go for 15 kilowatt, which is the middle pillar. During the life of motor, whatever the cost of possession, cost of usage, out of that we are paying only 1.1% on purchase of motor. We are paying 1.1% only on purchase of motor. Balance is all in electricity. If you make the same graph for bar for motor car, this would have been maybe here. So what I'm trying to bring your attention towards is, when you purchase electric motor for your plant, right, be very, very concerned about the efficiency of the motor, because it is going to kill you. If the consumption can be enormous, and maybe it may turn out to be very, very costly when you look at the total cost of usage. So I'm just bringing you to the Indian standards. As per IS 12615, they call MEPS, so Minimum Energy Performance System. And by that in India, in 2017, IE2 is the minimum required efficiency. Since 2017, we have passed 8 years. After 8 years also, we are stuck at IE2 motor efficiency, which is untouchable product for China as well as for US as well as for Europe. But we are still sticking to IE2 motors. What is the scenario at global level? In Europe, they normally lead the market on standards. From 1st July 2021, they have switched to IE3 motors, where efficiency matters more. So up to 0.75 kilowatt, they are okay with IE2 because they don't consume a lot of energy. But 0.75 kilowatt to 1 megawatt, they change over from IE2 to IE3. In July 21, we are still staying at IE2. In July 23, they have gone further. The chunk is lying here. If you look at the energy consumption by electric motor, they consume a lot in this 75 kilo to 100 kilowatt. They have migrated to IE4. So you can't use IE3 motor also in Europe if you are buying motor in this range, right? And you can't buy IE2 motors if you are buying in this range, but smaller output you can continue buying. This is the pace with which world has moved. Just see 21, 23. For last 8 years, we are at IE2. Indian government might also have some concerns because IE3 making is not so easy, and they have to protect interests of the small scale industry, motor manufacturers. So they are still allowing, but I think it's high time for government also to switch or change or elevate from IE2 to IE3 minimum.
What's the design difference?
Ultimately, you have to reduce loss. Efficiency can be improved by reducing loss. And it can be done by using more copper, by increasing the core length, and the dynamo steel which is used, which is the magnetic loss, right? Let me tell you, maximum loss is in dynamic loss, And now earlier grade 570, 630 were available. 630 is the lower grade, efficiency grade. Today they are 330 grade available. So by changing the electric grade, you can reduce the magnetic loss. By increasing the length of the core, you reduce electric loss, and both the losses are reduced. Then you reduce loss on fan also, because you don't need to cool so much, because loss has come down. There are a lot of other things to be done, but these are three basic levers. Doable. No, but it has got very big challenges in testing of motors, not only making, testing of motors. IE3 testing is not so easy. It's doable now. We cared for those small motor manufacturers. Now we have to care for the environment, right? But let me tell you, in our range, or more than 70%, 75% motors we sell, Siemens sells is IE3 and above. We have reduced that lot. In market also, I would say 30%, 35% motors being sold by all the mix put together is IE3, balance is IE2. Now one more question may come in your mind. By having IE2 installed, IE3 installed, I4 installed, how does it impact on our country on the CO2 emission? So I will take you to the next slide. Then one more line, I will talk more on this, CE. I will hold on to this topic for one or two slides. It's a very important topic. So there are some statistics, so I would have request you to be more attentive. We have got data, we get data, everyone gets data about motors produced in India. And everyone gives data that I produce this many IE2 motors, this many IE3, this many IE4. So India produces around 1.8 million number of motors. Right? If all of them are weighted, then the average efficiency of this motor, if it is IE2, it will be 87%. You imagine all motors are IE2. It's not so. But now when we have to set an example or have some analysis, then we have to take example. All IE2, all IE3, all IE4. Right? So if all are IE2, then efficiency would be 87%. This is not Siemens efficiency, this is efficiency demanded by standard. So someone can be better than this efficiency also. If all of them are IE3, then efficiency would be 89% and loss would be 11%. If all of them are IE4, efficiency would be 91%, loss would be 9%. There is some rounding off. For you to know a thumb rule, with every upgrade in efficiency class, your loss component should come down by 15-20%. So if my IE2 motor is having efficiency of 90%, loss is 10%. So IE3 should have 15% of 10%. So 1.5% lower loss. So a 90% efficiency motor IE2, if it is there, if you change to IE3, it will be 91.5. It's thumb rule. It may vary here and there, but these are all defined by Indian standard or international standards. Now just imagine, I have got data for 2023, all companies put together. If all those motors were IE2 installed in India, it would consume 78.3 terawatt hours. Terawatt hours is 10 to the power 9 units. By any chance, if all the motors happen to be IE3, it is 76.5. All of them were IE4, then it is 75.1. So power consumption would be less with higher efficiency. Up to this is also okay. Now, I'm not relating to money at the moment. It will come in later slide. I'm relating to the carbon dioxide. If all motors are IE2, then it is 57 tera TGC, right, is again a unit of carbon dioxide generated. It comes down. So if India decides to install only IE4 motors, that means we can generate 23 lakhs tons of lesser carbon dioxide. 23 lakh tons. Now, how do you convert into number of trees required to consume this, absorb this carbon dioxide? You will be surprised to absorb this additional. This is going to be there. Incremental additional carbon dioxide generated because of IE2, we require 9 crore trees. Only for incremental. For incremental carbon dioxide generation, we require 9 crore trees to absorb this. I don't say that don't plant trees, but if you plant trees and if you can reduce, if you can work upon this additional emission, the date given by Prime Minister 2070 can be advanced to 65, 64, 63. This shows what is the impact on environment. So if we can do so, we can have more greener land. There is some delay here. Will it work? Okay. So we will have more number of trees, and more number of trees will help us to reach our target line, net zero at earlier date. So now let's go to next slide. Why is happening with me only? So IE4 will help us to reduce CO2. Now we go to next level. As I said, hold on your questions on CE. How many of you know what CE is? Just raise hand if you know. Can you tell me what is CE required for? If you know, if you don't know, I'm also just fine, okay? No. So CE is a gateway to Europe, right? If you want your machine with motor and if you want to sell this machine to Europe, all your products should have CE, right? Why? Because Europe has gone to IE3, IE4. They don't want to disturb their climate. They still produce IE2. For whom? For us, right? China produces IE1 also. For whom? For us, right? But if you want to export China, they will not allow your IE2 motor to be exported. So we have to take care of ourselves. अपने घर का ख्याल हमको खुद रखना है. Now, CE is, as he said, it's a very important certification. It doesn't talk about only efficiency. It talks about a lot of ROHS also, impact to the environment also, chemical, hazardous chemical also, a lot of things. It talks about, even it goes beyond that also, values also, what kind of manufacturing you have. It has got one more point, okay. Now, as I said earlier that if I claim efficiency of 90%, then my Indian standard allows, IEC allows, 15% of your loss can be a tolerance. So when I give you a motor saying, sir, this is 90 kilowatt motor, you may find it as low as 88.5. And after that also, we are compliant. Because it's a government, IEC has given 15% of loss is the tolerance. Now, why this tolerance is given? Because when you produce 1,000 motors, then every motor will not be same, right? There will be some deviations. So standard is given just to take care of your manufacturing inconsistency. We give this tolerance. With lot of competition, discount, 80% discount, 85% discount, lot of competition, someone is giving very cheap motors. It so happened that tolerance appeared on the drawing table also. While designing motors, people, most of them, started designing motors with 89.5. And then this came into the notice of CE. Then what CE, they did at 1st July 2024 or 24-21, CE, they brought one more element, that you can mark CE only if you can produce one type test report, one, which has got efficiency, tested efficiency more than the or equal to declared efficiency. If I say 90% is my efficiency, I give you in my data sheet, I give you catalogs, then I have to produce only one certificate which has got tested efficiency which is more than 90 or equal to 90. It came to us also. And let me tell you, in this public also, we also found some gaps that didn't have some ratings where it was not. And then it was decided that we have to upgrade. When I'm selling you motor with 90% efficiency, I need to give you motor with 90% efficiency. Slight here and there is okay, but if I give 100 motors, 90 motors should give you 90 plus. 10 motors can give you lesser. Sir, you will be surprised with others. They didn't have any motor with one test report also with efficiency more than 90. And if it happens so, then you had some star here, C star. C is a star, correct? It's a quality of mark of quality. Except Siemens in this country. Every company, they drop C. When someone drops C, it is implied that they didn't even produce one motor with efficiency, tested efficiency equivalent to claim efficiency. So at times people tell us CE is required only for if you want to export to US or Europe. I said CE will take care of all your concerns. You are uninformed customer. You are not supposed to know all these things. You are industrialist. You don't need to get into all these tolerances. Just look at CE. If CE is there, then you leave it to CE. CE will give you, ensure you good quality and good efficiency. So it is said, it is not only seeing, but you have to test it. So that's why this punchline that it's not seeing which is believing, it is testing which is believing. And that's why we say that if you are buying motor with CE mark, it will have true IE3 efficiency motors. Now next one is plant auditing, payback environment and payback and environment impact estimation and financial viability justification. Sir, you touched upon a very important point, and I have reserved it at the end because I don't want to bring those topics during my session, 30 minutes or 25 minutes. So this is a very important job. As I said, we have spoiled this environment, correct? Climate, you, right? We are spoiling, right? So whose responsibility it is to repair it? It is ours. I normally make a statement. If you are a user, please support this cause. Install more of IE4, IE3 motors. If you are mediator like OEMs, machine manufacturer, please advocate, at least, don't lose your order, but at least advocate higher efficiency motors. And if you are manufacturer, then yes, it is our duty also to give you motor which is IE3, IE4 without much of the incremental cost. And we have to create awareness. And in all these three agencies, there is one agency which is I would like to call them as catalyst. Who is that? Catalyst to bring this awareness about IE3, IE4. Energy auditors. So, sir, those you are energy auditors here, maybe you seem to be a leading energy auditor, right? You are doing a noble job. Create this awareness not only for your own business, for the nature also. Please talk to more customers, convince them for high efficiency motors. Come to us for any information required. We are there to support you. And the last but not the least, hazardous substance in the motor. So any product you produce, it has got some substance. So there are guidelines by CE. They said, if you do not have, then you have to give declaration. Today in India, only Siemens is the company whose invoice carries declaration that this product doesn't have hazardous substance. Only company which you may not get Siemens invoice, but they get, our other partner get invoice, right? So Siemens only company who gives declaration that our product, this product doesn't have hazardous substance in the product. So now coming to this evaluate, so as I said, payment estimation, sir. So now we have defined a tool. Evaluate is the name of the tool, right? You have to simply enter data of how many motors, what rating, how many IE2, how many IE3, right? So just post the data in this tool. It will give you output, which will tell you how much units you can save. It will also tell you how much CO2 you can save. It will also tell you how many trees you can save. And this neutral tool, there is no charging for this. You can just log in. And if you are interested to go through this tool, right, how to use it, I will be showing a QR code in my last slide. You can scan it. And after you scan it, you declare your interest to attend this session which Siemens can offer, maybe virtual session or in-person session. And we will tell you how to use this tool to estimate energy saving. So this is the scan, maybe QR code. It is there on the last slide also. So if you want to scan, you can scan it. If you find it difficult to scan it, you can talk to our colleagues, right? They also can help you scanning. It's you just scan it, put your email address, contact number, and declare that you would like to attend this session. It can be for 1 hour, 1.5 hours. And I would request everyone to use this tool. If you are a machine manufacturer, you can tell me, your customer says, I need IE2, no problem, sir. IE2 will cost you 1 crore rupees. Give one executive report. Sir, if you buy IE3, I will charge only 5 lakh rupees more, but 5 lakh rupees would be paid back in 6 months' time. That is a job OEM also need to play. And this tool will help you calculating how much is the payback, everything. So now this is the film which was played in the Doha in COP28. And I like the film. It is very small film, maybe for 1 minute plus. Just read the words, okay? It is very appealing. It tells you one thing. Who will bring the change? You. Be it end user, be it a consultant, be it a OEM, be it a manufacturer, be it auditor, manager, it's you. So can you play it? Stopped. If that doesn't work, let's not waste time. Okay, leave it. So it's a very good, it's available on YouTube. Words are very, very catchy, appealing. So maybe you can, if you are interested, you can have a look at it. And it's frozen. So can you please go to next slide? Don't try, leave it. It's frozen. So let me jump the slide, maybe if they manage to play this. So I would like to conclude my session with one statement or one appeal. If you want this world to look like the first slide, right? No one would want this world to look like first slide. But if you want this world to be better place to live for you, your son, your grandson, your great-grandson, switch to i3, i4 motors, right? If you do so, you will contribute from your side. Let's keep this world a better place to live for our next generations. So thank you very much. And now, sir, I have noted some questions in my mind. So, sir was saying that it's not easy to prove and give justification to your investors that by upgrading efficiency of motors, how much is the payback? So, yes, it's a question mark because you can't check efficiency of motors at site, right? So what we do, few of us, if there are, let me give an example, twisting machines, they consume a lot of energy. So what we do, there is a machine which has got 2 motors, right? They are buying IE2 motor down below, and on the upper deck, we mount IE4 motor, right? And then we put an energy meter, not during that one day, but we run the motor for a complete cycle. They turn the yarn, they call it a door. How much energy consumed for one door conversion, twisting of one door. And after they see this, okay, here it consumes maybe 100 units, here it consumes maybe 94 units, and then I think it will be easy to convince OEM. Second point is, let me give one more example. There are a lot of textile machines in South also, big machines, and there is a motor which is installed. It consumes huge energy, and it's very critical. So now what we are doing, what Siemens is doing, we are supplying one motor as a demo unit at site. Right? They have got dozens of machines. They will be putting one motor of Siemens, which is IE4, and then they will see the performance difference, and then they will decide to replace all. One more point I would like to bring into mainly auditors' attention. There can be a situation if you replace X make IE2 motor with Siemens make IE4 motors, power consumption may go up. So let's pause here. So unite, which we are uniting today. Act, we can act in future. Maybe I hope, I'm sure we will get into actions from tomorrow itself and deliver to the earth. And this is the picture I like. Let's leave the world in this form for our next generations. And so I was saying that if you replace IE2 motor by IE4 motor of Siemens, your energy consumption may go up. So you need to be careful, right? Because at higher the efficiency, higher would be the RPM. And there will be a situation, if the pump is the case, then energy consumption may go up. So there are some care to be taken, like trimming the impeller. So please do that. If you have got VFD-driven motor, then fine. You can change the speed to the same level, and then you will save energy. But it is very clear, you buy any make of higher efficiency motors, it will deliver results for sure. And let me end with the last statement. Siemens engineers are different engineers. If you want to buy a motor, they don't talk in terms of polarity or kilowatt only. They will ask you which application it is. Not only Siemens engineer, our China partner, one of them is sitting here, Shalok, Sivananda. They are no longer box movers. We used to call the box movers, order liya, diya. No, they are value add now. So if you have any issue, any topic related to motor, do talk to us. Our colleagues are sitting here, China partner sitting here. We would love to help you out, okay? Because ultimately it's our responsibility also to save energy. And last point on motor selection, sir, it's not easy, okay? But motor selection is not easy. So I would request whenever you buy a motor, consult someone. If you look at us, we can give you our help, but consult someone before you buy a motor. If you want to buy a motor for VFD application, then there's something called IVIC C-class insulation you need to have. Otherwise, motor may not fail in 6 months' time, but will definitely fail in 2 years' time. So motor for drive application is different, motor for the line application is different, motor for screw compressor is different, motor for fan is different. So it's different motor, and I would request you to look at us in case of any help required. Thank you very much. All the best. Thank you.
Thank you, sir. Any questions?
Yeah, any questions?
What role does EMA play in converting from I2 to I4? Are they not playing any role?
EMA is what?
What agency can actually do this otherwise?
Let me tell you, EMA is a kind of association. Association of user, association OEM, association of manufacturer also. And within EMA, there is something called EMA RM, rotating machines. We also are a member there, right? So EMA RM talks to MHI, right? Talks to Commerce Ministry, convinces them to go for remove IE2. There are representations also being made. We are fighting very hard. We have to respect government also. We have full respect for government because they have to look at all aspects of life and business. So there's some delay, but I too would be out of the market maybe maximum 1 year, 1.5 years. We do our job.
Sir, we appreciate your excellent presentation, and we agree the
and misuse term or word, etc., because there's a variety of understanding of what real lean is, and people do it in various different kinds of ways, and they get varied results. Most of them are left not satisfied with what they get. If you use lean manufacturing, manufacturing is actually how it was coined in the 1990s. Lean actually originates from Toyota. And when people put, what Toyota does and how it does together, they called it the Toyota production system. And the word manufacturing probably, comes out from the concept of Toyota production system. It actually is not related to production itself. The real way to call it would be a lean business process or Toyota's business process, okay? The philosophies and principles that originated there are so universal that you can apply it to any kind of business. I myself have done work in more than 30 different industry segments, very, very diverse, from very
hardcore engineering to floriculture, from refractories to very high-end electronics, from software to food processing, pharmaceuticals, jewelries, watches, you name it. It can be, it's actually a way of how to think and conceive the best business process. It's a complete strategy work. Okay? So when you become lean, when you successfully implement lean, it's the highest form of efficiency a business process can get. Today, there is nothing known that is more efficient than, becoming lean. It beats all the kinds of other wall decoration certificates that one can aspire for. One of the reasons why, it is so successful today and every organization aspires to become lean is because there's a difference between conventional thinking and lean thinking. The conventional thinking always thinks in terms of silos, just into patches, like just to use a very random example, like you measure the efficiency of a machine or a motor or whatever, in lean, what we actually do is we go way behind that and we look at the entire value stream. And it's because of this particular thinking that the lean thinking or the lean process can actually eliminate a lot of wastes that are not supposed to happen but are happening. And waste is, something that should not happen, but it happens. And why do people allow it to happen? Because people are used to doing things the way they have been doing before, or somebody else has been doing it before them. So when they see it, they think it's normal. They are not able to see the waste. So you need to develop, lean eyesight, or wear lean spectacles to be able to see through the process what are the different kinds of wastes that actually happen. And these are industry segment specific. In manufacturing, there are 7 well-known wastes, but when you go to different other areas, there are a lot of other ways of how this can be measured. What do we do in conventional thinking? When we see a problem, we solve the problem, right? We call this as eliminating a problem. But in lean, we call this, a very dumb thing to do. Why do we call it dumb thing to do? Is because in the very first thinking, we have allowed the problem to be there. We may not have seen it before, but then we see it now and we eliminate it. So the two most important, places where wastes can be eliminated. And when I say waste, waste also connects to all those things which you guys are talking here today about carbon emission, things that can contribute to carbon emission. So it also includes that. So why, we call this as waste elimination as dumb? It's because once the waste is there and you are able to see it, you are able to see the problem behind it. Using the tools that are available to solve problems, we can solve the problem. But that's not the intelligent thing to do. Why that's not the intelligent thing is because the process before has been faulty. And because the process before has been faulty, the result has been, has generated a problem. So problem prevention is what we do in lean. We think through the process end to end, from start to finish. Whether, if you take an organization, we start from the customer end till the last vendor. Every single micro process is well thought of. Everything that is not required to be there is removed. You apply the same thinking to product manufacturing, to product design. You see, more than 90% of the problems can be prevented at two stages, the product design and the process design. And when these are not perfected, you will end up with facing some kind of a problem, some inefficiency or something that gives you the wrong result. And then we try to eliminate that. And that is what we say we can avoid. We call it idiot proofing. Why is it going back? Yeah, okay, sorry. I was holding it the wrong way. So the goal is actually to enhance productivity, efficiency, and flexibility through continuous reduction of wastes in manufacturing. Now, I've used manufacturing here, but it can be anything. It can be a hospital, it can be, it can be a hotel, it can be an educational institutions, it can be anything else. Continuous is the important word. It's not just solving it once. When we solve a problem once, we have made an improvement, come to a better level. That's not the end. That's when we search what else can we do to make that even better. And that is, what lean thinking and lean manufacturing is all about, or a lean business process. Just to give you, a little insight, I'll give you just a couple of examples. We'll take a manufacturing industry, we'll take a process industry. Now, I was given a problem in Indonesia once with an American joint venture company which had been set up there. This company had existed for 5 years. There were people, there was factory, the building was there, everything was there. People were trained in the United States. And after 5 years, also, they had not produced machine number 1. So, for 5 years, they had been doing their work, doing whatever they were doing, emitting carbon dioxide or, emitting some waste. So, using lean thinking, and I won't get too much into the details of what we did and how, using a dual strategy in play to solve these problems, we were able to get this factory up and going in less than 6 months. The factory was thumping out production. And then I was told this was a very, very prestigious American collaboration. So when this factory was fully running in less than 6 months, the president of the country with the ambassador from USA, the ministers, they all came, landed in a helicopter in front of my factory on the football field to come and see what actually had happened. So what had actually happened here was from just running to produce nothing and creating so much waste, now, and without capital investment, without funding the production, that means without the funds for the required cash flow, we were able to do this. And that was because of the dual strategy. One of it was to how do we source these components that we need to build these machines. And to source, we would need money to pay them. How do we pay them without having the funds with us? So this is where lean thinking and the idea of how to get down to every single micro process, identify what is required, what is not required, eliminate the waste, and make it so super fine that we were able to buy what we needed to build the machines from various people, get the, everything that was needed in the plant, and a lot of it had to come from overseas, that means including the shipping time, build the machine in a very specific time, test it, and then deliver it to the customer, receive the money, and pay the suppliers. All of this to happen in less than 30 days. So it took about 7 days to bring in everything. It took 2 days to build the machines, test it, run it, and deliver to the customer, collect the money, sit with it for the next 2 weeks, and then pay the supplier. So how much do you think, when you think of this, in terms of your carbon, how much of it would have actually been saved? Because it's just not about the machines that run. It's just not about, one thing or the other thing. It's not just at one location. It's at multiple locations. And where everything had to be done with, certain speed, high velocity. And that would save. So that's one of the ways how, if you really become lean, you can actually save a lot of this. Another example from a tier 1 industry here in India, supplying components to all the big automotive chaps here. So when I was shown the problem, the factory was like, I have a thumb rule, right? When I go to a factory and see, if the factory has more than 10% of the factory floor occupied by components or inventory, it's not a manufacturing place, it's a warehouse. So when I looked at this place, this less than 30% of the factory was workspace with machines and people assembling things. More than 2/3 was inventory. So we went to work, again. So you imagine, like, if that is the kind of scene, how much of wastage would be there? When you talk of inventory and when you talk of wastage, inventory has to be produced, for which you use power. The power that you have utilized is you're not able to sell that power to your customer because you're storing it in the form of inventory. And you keep accumulating this. That means you keep wasting and wasting and wasting of producing carbon and carbon and carbon. And then there is, this is the way how you create a lot of what is not wanted. So when we got down to this, to cut the story short, there are a lot of things to be done to solve this kind of a problem. But on that day, now, finally, what was the factory able to do? Every day they would receive an order from their customers saying the customers want certain number of assemblies each day. Customer A, B, C, and D. They would give certain number of assemblies of a particular type, what they wanted. So this would be known to them in the beginning of the week. Now, the way this whole thing was set up using lean thinking is what the factory needs to produce and deliver today. The night of, before the morning, that is the night of the previous day, the raw material would come in and the raw material would go to the place where it was required to be worked on. There was no store. The raw material would get worked on, and where assembly was required would get assembled, and in the night, it would go to the customer. So the owner of this factory would come in the morning and go home at night with a clean shop floor. Now, can you imagine in terms of carbon efficiency in this kind of an operation? This is not the end. There are other things in lean You see, lean constitutes of two major things. We call two big baskets. One is just in time and the other is Jidoka. Jidoka is more related to the quality aspect. Just in time is a basket of tools and techniques, and there are more than 98 or 99 tools and techniques that are available to us in lean that we use. A lot of these tools and techniques are like the software in your computer. They are connected, and you can't use one or two by randomly picking them up. Unless you use the complete network that is connected, you won't get the best possible results. So if you do this, then any manufacturing plant can become as efficient as the example I just spoke to you about. And there are such factories working. I had seen Toyota does train its suppliers, and I had seen some of Toyota's factories which came very close to this, Toyota suppliers. So that's another way how you can, actually save a lot of carbon emission. Because in various processes, there is, carbon that is being emitted. A process industry, cotton, textile, technical textile industry. So when we first walked into this place, this factory was also it's here in India. It's also in existence. It was running for 5 years and newly installed plant, hundreds of crores of investment, but they were not able to produce. And factory used to run 24 hours a day, consume power, produce nothing, almost nothing. So again, using everything that we have got in the lean basket, this factory started running from not being able to make money in 5 years. In the 7th or 8th month, they became operationally profitable. And thereafter, they started to grow. In a very short time, I think they grew in terms of turnover, about 20 times or 25 times, something like that. So if you convert this into thinking, like what would they be doing in terms of everything that they would consume, all the machines, all the equipment, and there's a lot of power. Textile machines require a lot of power. And when you run them and you don't produce anything, you are generating nothing but waste. And when you think lean and you think how can you make things more efficient and more productive, etc., you actually can save a lot of your carbon emission, etc. So how does this principle actually work? What we do is we start to define, the value that the customer expects you to deliver, or the value that you want to deliver to your customer. Now, value is not an easily understood thing. Most people understand value as quality, cost, and delivery. But if you read the research work of C.K. Prahlad or Dr. Hamel, they talk a lot of things about value, and they explain why most customers can't actually define what value they want you to deliver. But one simple way to look at value is, how do you want to differentiate yourself from your competitors? How do you want to beat your competitor? Not just talking about the quality, cost, and delivery. Now, this is like a given platform. Everybody can do this. So when you identify that, then develop the strategy how to deliver that. If you have difficulty with that, you can even consider the product that you are making as the value that you want to deliver. You want to deliver that product successfully to your customer, right? As an organization, if you go to your customer, you identify the need of your customer or the problem that your customer has. You want to solve that problem and give him a solution. The solution can be in the form of a product or a service, whatever it is. Now, this actually goes through various stages. You need to design the product. If the design does not exist, you need to design it. And then define how are you going to produce it. So every single aspect of this, from the customer till the last point when you deliver, how are you going to do this? This needs to be designed. This is the basic strategy of how your business process is going to run. And when you design this business process, if you are able to get deep down into every single process, every single microprocess, including defining, the charts that need to be there, the checklists that need to be there, the reports that need to be there, everything, standardized, nothing other than that, nothing extra, nothing unwanted, because every person can come out with, his own thinking saying, I need this, I need this, I need this, and a lot of it may not really be useful. So, design, yeah. And then once this is designed, then what you do in the implementation, you have identified various necessary steps, and when you look at what necessary steps, you try to eliminate everything that is not required to be there. It requires a lot of deep thinking. And one of the things that will help us here is to think of it in terms of flow. Now imagine a river flows from upstream to downstream. And the river flow means it does not stop. And we got to think of every process, whether we look at a hospital, whether we look at manufacturing in similar way. If you take a hospital example, now a patient comes into a hospital, and a hospital, what does the patient want? Patient has a particular problem, wants to meet a particular doctor. So let's say the patient needs to go through to reach the doctor. So there are various steps before the patient actually reaches the doctor. How efficient can this be made? There's a lot of waiting time, there's a lot of wastage of time here. And then the doctor examines. You need a blood report, you need an X-ray, you need a scan, and then maybe you need a surgery, recovery, and go home. Now, how can you connect all of these so that everything happens without, loss of time, wastage of time, just to make things more efficient? If the patient needs to travel between these from point A to point B number of times, now there's a lot of wastage there. So these are very simple examples, but then these are the ways of how one can think through every process and eliminate. Every step that you eliminate, which is not required, you save something, and you get, in some direct or indirect way, carbon saving too by that. The way to think is, in an interconnected way, not in terms of silos, not in terms of single processes and making them efficient. Now, somebody here from component manufacturing will understand this. If you take a particular cycle time for a particular component to be made, now you want to improve that. So you work out a way how you can reduce the machining time on that component, and you say, I've saved X number of seconds. Now, how does that help you? Does that really help you? Because there would be other areas that you would not have seen where wastage is being created, and this saving, although on the paper it will give you a saving, but it will not reflect on your balance sheet. And one of the things with lean is when you work with this proper lean thinking, everything that you do, you will see it reflect on your balance sheet. Your P&L account will show the difference, always. We also, don't jump into a lot of sophistication straight away, because we have a visual tool we call as, visual signaling, where we use this to design systems which communicate visually. So it tells every next process what should happen, who should do it, without anybody telling anybody or any other form of communication. So we do avoid a lot of softwares that do this, just because it can be done in a more simplified and cost-effective manner. We call this as, visual tool or visual design. So if you look at a river, why does the river flow towards the sea? Sea is like its customer. It pulls. So flow will only happen if there is a pull. And the pull in manufacturing can be always only from the customer side. Customer can be an end customer, or the next process is the customer to every previous process. If there is no pull and we are trying to push from the back, what happens? If you take a thread and lay that thread down here and try to push it from one side, it crimples. And that crimple is nothing but the wastage that you get in the form of your inventory. You would have used a lot of resources to produce that wastage, but you are not able to deliver it to your customer straight away. Whereas you go to the front end and you pull. Every inch of the thread you pull, you're delivering it. That's a big difference in how we think in lean. That's also how we convert stationary inventory into flowing inventory. The example I gave you of that factory, which had 3/4 or more than 2/3 of it was inventory, where everything disappeared to become zero. This simple thinking was used there. No push, just pull, and just do what the customer wants. So that's how you become efficient. And when you become efficient, everything reduces. All contributors to your carbon, directly or indirectly go down. Lean is a journey. It's not a destination. At no point in time does anybody become completely lean. Even Toyota today will not call themselves lean. They will, strive to find problems that exist, and they want to solve them to become even more lean. So what we do is we repeat this cycle over and over again, every day, many times a day if required, and become more and more efficient. And in this process, we are identifying everything, all inefficient motors, inefficient systems, idle power consumption on equipment, how to make that better, A to Z, everything, even the waste treatment, everything, carbon emission is part of it. So we measure everything, and then we try to identify what are the contributors, where does it begin, how to plug that, or can we design a process where we can overcome that altogether. So when you imagine when you save your throughput time by 95% or even more, how much of your carbon emission you would have saved? Throughput time is like what does your product take from start to finish? If your product is taking from start to finish, let us say, one worker, if he goes away from his workplace, then his value addition reduces, goes away. So everything would happen the way it should happen, and order would get executed, loaded onto the truck. Only then the sales department would do an invoice, and there was no supervisor or manager involved in between. We treated them as interference and not as anything that would facilitate the process of manufacturing. Now there is a trick in this. The trick in this is to hone this system and set it up such that the workers are able to handle this. They should understand. And all signals, everything that was communicated was visual. The guy has to see and understand what he has to do next, just by seeing. And there is a way, there is a technique, there is a methodology, it's available to us by doing that. No software involved. In fact, I did not even have one machine with PLC. Everything was completely manual. So somewhere in 92, I think, Toyota came to India. They went to different people, whoever had invited them. They did come to us. They were to visit my factory for an hour in the evening because we had an airstrip in Hubli. They were to land there, walk around the factory, have a cup of tea, and then they were to go to our head office, which was in Harihar, where my MD was waiting for them. And I was not in the factory that day. I was in Delhi. So I told my chaps, small thing to do, take care of them. They came, they were taken around the factory. Because the factory was completely on a visual system, completely, 100%. Nobody needed to explain anything to them. When they saw what they saw, they did not want to go to Harihar to meet my MD. They asked my chaps, can we stay here for some more time? We want to see more of this. So they were housed there. They stayed there for 3 days. They went behind every worker to see how does he understand what to do? How do these fellows solve their problems? How do they identify the problem? How do they identify what is to be improved? How do they do these improvements? How many times do they do this in a day? And when they saw that, they went back and decided, this is the company we are going to join hands with. And that, gentlemen, is the story of how Toyota came to India. Because what they saw was, as I call it, a poor reflection of what they did in Japan. And when you become completely lean, in any kind of process, it doesn't have to be manufacturing. It can be anything. Like I said, it can be software, it can be, hospitals, hotels, educational institutions, or any goddamn thing that is done. The lean business process, which will eliminate everything that is not wanted, saves you a lot of carbon, a lot of other things, a lot of money, and helps you make a lot more money as well. Thank you so much. If there are questions and there is time, we can, otherwise.
Thank you so much, sir, for the wonderful insight on the lean manufacturing. So we usually say change is the only constant.
Yes.
So with that being said, with 30 years of vast experience, seeing the shop floor for 30 more years, and can you talk about the one time you had a tough time that stands out bringing in the change for the better?
There is no one time. There have been a lot of tough times. You see, because when you want to change, and this is the basic work I do in You know, the hundreds of organizations that I work, it's a cultural change. And transformation is nothing but cultural change. You know, in the process, we change all the business process, everything. You're dealing with people, and people come with a mixed bag, you know. People are very comfortable in the way they are thinking, they're used to it, the way they are doing things. They don't want to be discomforted. Change disrupts their comfort. So there is no one.
Yeah.
You know, there have been, it's a journey where we go through a lot of these difficulties, you know, where mindsets are, you know, all of these things.
How did you strategize? Like understanding the psychology was part one, but then how did you strategize that implementation?
What I do is there's a simple trick in this. No talking. You know, a lot of people do this mistake by trying to talk first of what they want to do a PowerPoint, do a presentation, and tell them this is this. I am actually quite opposite of this. I just take them through the process. Now, for example, if there's a particular process that is going on, modify that. Don't lecture about it. Don't justify why this is. Take them through the changed process. Now, the changed process that we would have thought through would be a better process naturally. It will give a better result. They will see the result. I give them the credit for the better result. Motivates them. They continue, they practice. That becomes way of life. And then I tell them, you know, what you guys have done is called this in terms of, you know, all jargons or terms or whatever this and this and this is.
True that. That's what a true leader also does.
So there is a lot of psychology that comes to play here.
Yeah.
You know, I do talk about psychology. You know, creating neural pathways and stuff like that. But that not everybody will understand. There are some videos I show them, so the pictorially they can understand what it is. I do use that. Not so much, but I do.
Thank you for that. And there's one more thing that I would like to mention. The most dangerous kind of waste is the waste we do not recognize. This was mentioned by Shigeo Shingo, a prominent figure in Toyota production system.
Yes.
So with 30 years, how do you train teams to develop the eyes to recognize hidden forms of waste, especially those that have been normalized over time?
So, see, it's by taking them through a journey. This cannot be done through a PowerPoint or a lecture or, you know, it's not done. You have to take them through that experience. Experience is the only truth, okay? That's the only thing that one can believe. So they have to be taken through that experience. And because I work with them, I handhold and work with, you know, all my clients, from the MD to the shop floor worker. So when I take them through that journey, they experience it. That experience builds belief. Can't teach like a classroom. You know, these attempts have been made by college professors. They have written books. There are a lot of articles, publications, a lot of PowerPoints available. All of that is there. Use them, zero success.
Thank you so much, sir, for that answer. Anyone else?
I think, hi, I'm Dinesh. While answering her second question, you mentioned there is already, you know the better process and you can take your team and walk that process along with them. But let's say if I don't know what is the better process, right?
See, there is this thought of a better process starts by understanding that there is a problem. There is something going on. There is a problem. We understand what that problem is. Now we want to solve that problem. Solution to that problem may come through doing a different process. Correct? Then we think through that process. There is a way of how we do that. It's called brainstorming. And brainstorming, there is a particular way of how brainstorming should be done to be effective. So we follow those simple things, and then we arrive at what can be a better process. There are certain tools also that we can use if required. We can map the existing process. We can identify what's going, we can measure everything in that process, identify what's going wrong, and then reimagine. You see, all the change and improvisation and everything that we are talking about involves the ability to visualize. Where do you want to be in the future? When you say better process, what will it be? What should it be? What are you trying to overcome? Right? So when we take that into account, we are able to design a new process for it. It's not difficult.
And what kind of tools are available?
Can we
to
park
map?
this question slightly
Sure,
later?
sorry.
Because I think we are really running short of time.
No,
We have
no
two more
issues.
presentations
Sorry
to
about
do.
that. I will connect with him
Yeah,
offline.
please, yes. He's going to be
Thanks for
available.
opportunity.
Thank you. Yeah, I know there's a lot of questions. Senior leader like Sanjeev sir will attract a lot of questions, and please be there around, sir, to help us clarify some of questions.
Thank you.
Thank you so much.
Thank you so much, sir.
Happy to introduce the next speaker here, Mr. Navratan Kataria from NASSCOM. So he will cover the deep tech and the digital transformation aspects, how that can accelerate the energy efficiency side. Over to you, Navratan.
Thank you. Is this too loud? The pointer, please. All right. So we were recently in an event in Leela Hotel, and it's a 7-star, and Madhu was also there. And Leela serves very good food. We all know that. At the end of it, as a feedback, people still said, if that dessert was a little less sugary, if that paneer ki sabji was not so good. So that's the same situation that we all go through the situation, dil mange more. So after going through all the big presentations here, all the gyan that you got, we still need something more, right? And that is the reason why if you consider two organizations, one is IGCC being represented by Madhusudan. The Germans and the Japanese are the most advanced when it comes to, say, for example, manufacturing. But we are not talking manufacturing, but there is a lot of energy conservation requirement from that side. The center that I represent, and I'll be showing you that, is getting every 5th day an international delegation. And the most number of delegations come from the most advanced manufacturing countries, which are Japan and Germany. With that, let me introduce you what I'm going to be talking to you. There are a good number of logos here, and I'll explain to you why there are a good number of logos. There's the Ministry of Electronics and IT, there's a Government of Karnataka, and NASSCOM, which is an association of all IT companies in India, representing 3,000 companies, $250 billion industry, and does take care of the digital part. I run the innovation part, and when I say innovation part, it's basically to do with the startups. And innovation, of course, can come from any SME or large players. These are where we say deep techs are. Some of these technologies you are aware of. AI contributes the most of it. We have IoT, and between these two-thirds of deep tech technologies are helping today in any sector, in any technology that can be influenced, impacted. So these are just some of the numbers of the startups that are working, and this is what we deal with. So what we do is, today we are looking at digital adoption, and over the course of the day, you would have seen that almost everything that we do today, from UPI payment to running our own show, whether it's a product or manufacturing or service industry, we do require digital intervention. And digital, fortunately, we are the 3rd largest startup global player in the world, both by number of startups as well as by the number of unicorns. What we have gone through is to see, and this is a lot of blessings from the government also, because they want to push a lot of digital adoption within the SME sector. We'll talk of SME sectors. So there was a survey done, and these surveys are known to have given some very good insights of what could be the reasons why things have not moved the way it should have moved. If you look at, there are a good number of big players. They've got already their own teams which do digital adoption. We're talking of SMEs, where the owner himself would like to know what is my ROI. The biggest requirement today for any intervention is the ROI. And we've gone through these surveys of, I know, but I do not know what to do, or I have recently adopted. What I have adopted is probably automation and not digital intervention. So we go through these kind of things. We have done this research just to identify and probably give the feedback to the government to say where does the SMEs industry today requires intervention. So we also went through some of the apprehensions. So one of the biggest challenge that every owner of an SME says, I don't have time and resources to work on new initiatives. Chalta rehne do. Whatever is working is good enough for me. But in this day of competition, you can't run this. IoT and AI are only for large factories. ROI is the biggest requirement for any SMEs, right? That's the second. The third is everything is working fine. Why should I change? The fourth is I have not seen examples of MSMEs getting benefits from digitalization. I mean, this is good to talk in events like this, but show me some success stories where I can say, yes, it's got some impact, and that impact brings some rokda to me, brings some efficiency to me, makes my customers smile. We have not seen that example. And I have already invested in digitalization through robotic systems. Now, there's a big difference. I mean, people have used robotic system, automatic conveyor belts. We're not talking about that. We are talking about digital intervention. And so what we have done is, I'll give you a few examples just for you to understand, and we're talking about energy conservation. So I'll talk about one of the companies which what it does is, it gives you tangible results in 60 days. And what it says is, if you don't like me, throw me out. I mean, this is the strength of a startup. The confidence that they build is that they say, you try it, you don't like it, throw me out. The second day, don't pay me a single rupee. But they have been proving that in 60 days, you can see, and these are the technologies that they use. They use AI, they use ML algorithms, they use AI, Gen AI, they use IoTs. Name any deep tech that they have not used and they are already using it. They deliver and they collect, visualize, analyze, and recommend. This is the typical process of any digital intervention. Anybody, like we heard of Tor.ai, right? This is something which is generally done by all of these digital interventions. What they do is they cover almost everything in your factory, not on the assets, but also the processes. So you cover almost everything what goes into this, and unless you monitor them, measure them, you cannot really judge whether what you said. And you know, we all know that a guy who comes to sell energy conservation, or for that matter, GHG, so fashionable to talk. Usually, if you remember the olden days when the custom officer used to look at you and say, you are a smuggler unless you prove you're not. So it's the same situation when the energy conservation guy sells his product or solution. We do not really believe in what he's saying because we have not seen examples of it. And the purpose of all these kind of events and the German Chamber of Commerce is to prove. And why German? Because they've done this in past. But I must say that they are also picking up stories from India of how digital intervention can be added to the state-of-the-art manufacturing machines or processes or technologies. And this is where you've seen people claiming 11% increase in productivity. I mean, this is quite, if you look at the profitability of most of the manufacturing companies, these are in single digits in general, right? Unless you are so good, you are the only guy on earth. 11% in increase in productivity is supposed to be quite a good profitability increase. People say in terms of carbon footprint, 20%. And of course, there are companies which are helping you to monetize the GHG reductions. Because people usually believe that when it comes to large factories, large entities, it's very easy to calculate, go to the government and take care of carbon credits and monetize it. For SMEs, it's still difficult. But people have started doing it, and let's start doing it. And the digital component is actually helping you to accumulate whatever you saved on Earth for the carbon. We have seen in operating costs 21%. So these are the kind of examples which are average over across different sectors. People have worked in hospitals, to manufacturing, to process, service industries, all of them. We will take another example, which is pay-as-you-save solution. Lots of SMEs, since we are talking about MSMEs, lots of people say, look, I don't have any money to give to you. I don't even believe it, whatever you say. So what people have said, pay as you save. So they will come and put some monitoring devices, put certain processes, do some intervention and say, if you were paying, say, an X amount of electricity bill and you saved, say, 20% of it, give me a portion of that profit. That is what used to be happening in energy conservation, but with the digital intervention, it's very easy because most of the conflicts between the buyer and the seller happens. Oh, look, my production actually went down. So you can't say that's the energy saving that was because of you. It was probably because my production was low, or whatever the other parameters which are not directly because of you. And if you do not have any mechanism to prove it, you will not get your bill passed. So we have to measure in every step of energy efficiency, and that's what these guys do. GHG measurement. This is another company which has gone word over. They do everything that is required in GHG measurement to evaluate, to make you digital twins. And if you think what Sir said, visual, there are people who say that if I were to do something and run through the process, if it doesn't work, danda lag jayega boss se, right? Can you do a digital twin to simulate without actually working on the process or the manufacturing line? What will happen if I change this parameter, this manufacturing line? So that's called digital twinning. People can actually replicate your modifications on a digital twin. And this is where a lot of digital interventions have helped a lot of people to see if they, whatever is in their mind, actually will bring something better or not. So this is what digital twinning does. Machine monitoring. So digital intervention is not for energy efficiency. Of course, that is the talk of the day. But if you're monitoring a motor, for example, you're measuring the temperature, the vibrations, the noise, everything that you can measure, the voltage and the current and the fluctuations. All these are not only giving you insights on how to conserve energy that it is consuming, but it also predicts failure. It also optimizes. It does a lot of things which improves the life of the machine and can predict, boss, this bearing is likely to fail in 3 months, please get a spare part immediately. So you're not also holding a lot of inventories. We had, one of the questions was, how do you measure? The biggest problem is any monitoring of energy conservation is people expect every factory, every load, every lathe machine to have its own meter, which is almost like impossible. Where's the money to get that? So there is startups who put a single meter, and there's an AI engine which checks the signature of every voltage current variation for every type of load. So if you have a compressor which comes on versus a fan, a blower comes on or goes off, there's a different signature of the voltage and the current fluctuations which happen onto the grid, onto the input grid. And this is what it recognizes through its ML algorithm. What it does is, with a single CT and a voltage measurement at your input, you can actually monitor the energy consumption of every kind of load in your factory. Isn't it great? Because all you have to do is just put a very small CT and PT on the input. The AI algorithm over a period of time of a week or something will learn all your loads in the factory and then tell if there's one motor which is drawing more current when it starts because the compressor bearing is not working properly. So for digitalization, data is the key source, we all know. And how do you generate data? Thankfully, today we are in a very good atmosphere where data is being collected by a lot of, and we will be using that. I mean, the first step is data collection. But data capture, so sensors, e-logbooks and devices are already happening, and a lot of good use cases are happening on that. But that's the starting point. You process it, you diagnose, and the intervention is the most important. Now, all these parts, and of course, people know AI is very fashionable. It's overused term. But I think there are very great number of examples, not only in Karnataka, but the rest of the country, which tells you that having gone through the exercise of collecting data, anonymizing it, if it's a health tech related, for example, or it's something where a user personal data is required to be private, if you can actually use AI to learn from all that data that has been available, that gives you immense potential of interventions. And those interventions for any MSMEs are highest on ROI. Today we have a startup which worked 20 years in Germany, has come back into India. He's helping SMEs and he says, I'm not charging you anything. I'm charging you the day you think that there's an impact I've created. Because he's trying to put in all his knowledge that he's gained in Germany, along with the digital innovation and the strength of this country through the startups, put together to give it to the SMEs. So what we have to do is how to adopt it. And this is what we have done. Now, we have a step-to-step approach, which I'll quickly run through. You go through the digital roadmap. Where do you stand today? You identify the manufacturing, or if it is a non-manufacturing also, you identify where are your major challenges and what's your focus areas, but prioritize them. And in the first year, we always look at low-hanging fruits, just to show that whatever you did does work. Automate repeated production. There's a lot of manual work which can be automated, and this is called RPA, robotic process automation. You have connected machines, you have proof of concept advanced solutions. So in general, with the startups, it's not like you invest the whole of the CapEx or the OpEx, right? Unlike the vendors that you talk to, most startups work with a proof of concept, which means that you say, this is my problem. He comes with a typical solution that this is what I am going to do it. I will try, put a demo plant. If you like it, you place me a purchase order. You know, this is the beauty. It's like, you know, almost everything like Amazon. You don't like it, throw it back. This is how startups work, because typically these are not off-the-shelf available solutions. They try to identify individual problem areas and then they will work on it with their IPs, with whatever they have been doing. 60-70% of it will be their IP. And then once you're done the POC and the POC has been approved, you're liking it, you say this is something exactly what I wanted you to do, you scale it. You say deploy it across my factory. And we have seen factories which said, you're deploying 2 factories, and then once this is successful, there's a proven ROI on it, the management is happy, they pump in more money, and then they say, put it across all my factories across India, and then it goes global. And there are a lot of startups from India who have their footprint in every corner of the globe. So, of course, needless to say, we are working on efficiency, profitability, and growth. This is what is required. What we are doing is, the government of Karnataka has spent, this is before the Global Invest meeting which happened 3 months back, where the government of Karnataka said we need to digitally help the SMEs in the Karnataka. So what they said is we were told to train them, run through them what are possibilities, and some of them would come forward and say, so we trained almost 2,000 SMEs across the different clusters of Bangalore. The good thing is that the government said, I'll give you up to 5 lakh rupees subsidy through it. So you do not have to worry about ROI. And most of the interventions that we have seen are within that range of ROI theoretically, which says that you just have to say, I do, you know, like a typical marriage in Christians. What we have done is we have gone through the clusters at different districts in the country, in the state, and this is a very great example where, of course, some of the winners, both the adopter, which is the SME, as well as the solution provider, were awarded by 3 big VIP politicians here. You can see some of the pictures here, and 2 union ministers. The purpose is, if you've done good, if you've taken that first step of trying to do digital intervention, this success story has to be broadcasted. This is good for the SME as well as good for the industry as to learn that these things actually work. It's not just a hearsay. So what we have to do is, if any of the SMEs in this, or any of the consultants, auditors, whoever want to do anything in this area, What all you have to do is just apply to the government portal. It goes through it. We give you the best options available through the startup world or the innovations of the problems that you think are to be prioritized. And 5 lakh rupees comes directly to the vendor. So you don't have to write a check because the cash flow doesn't go through you. So this is what we've been doing. Who we are a PPP model, public-private partnership program, which we were born 9 years back by the Ministry of Electronics and IT. The secretary of the ministry sits as chairman of our board, the principal secretary in the state, and we are in 4 states. The biggest strength that we do is we have done 550 use cases in last 9 years. That makes us the largest player of co-creation. This is called co-creation, and I'll explain in a minute what is co-creation. We believe that deep tech startups, if they produce a bottle and say, this is the bottle, you take it, you will not take it because every individual adopter requires something which is customized. So what we say is if the startup and the adopter can sit on the same table and then they can discuss, magic can be created. This is what we call co-create. We've done 550 industry use cases, the highest in this part of the world. And what we do is we do not invest into a startup, which is the way most of the incubators and the accelerators work. They make money by investing into their equity. We said we want to help every deep tech startup in the country. And not only that, I also had the international partnerships with 10 countries. When we want a solution for any global country, we look out, if not available in India, we go out of the India to connect with our bilaterally connected countries to find out if there's a startup in that country. It doesn't matter to you where you get the solution from. So we connect the industry to the startups, that's their biggest role. But academicians are important because the core engineering and technologies are born there. But while they are ready for commercialization, that's where we handpick them. The one government, because government is a part of us, so, and in many cases, policy interventions or any schemes that has to be brought, we have to give that kind of feedback as an unbiased platform. So we'll tell what is good and what is not good so that it goes back to the industry. So we are doing that on a regular basis. In deep tech, if you count that 3,000 deep tech in the country, we're connected to 2,500 of them because for us, everybody is something which we can use them and support. What we also look at is we run incubators. We have a lab which is electrostatically protected. It's an HSR lab with test and measurement equipment. But what we also do is every year we add a new technology. And every year we add a new sector because we have to also learn what that sector needs are. So we try this and it takes 3 to 4 years before a new technology comes to a scale that can be commercialized. So for example, last year we added quantum computation. And you'll be surprised how quickly this actually happened. Thanks to the COVID vaccine development, pharma companies were never doing drug discovery in India because they thought it's not our cup of tea, right? Today with quantum computation, things which used to take 7 years have actually worked with a very large multinational pharma company in India sitting over here through quantum computation because it reduces the time of calculation or the drug discovery to almost 1/30th. So we do this. And of course, last year we added space tech much before the Chandrayaan was established on moon. So this is what we do. We were inaugurated by the Union Minister of Ravi Shankar Prasad and Priyank Kharge, you can see over there. This was in 2016, he's again our minister. So we try to work with both the political systems in the country. We know how to balance things. For SMEs, we also know that you need to be neutral and be able to work with any government that comes in or out. So that's it from me, and if there's any other question that needs to be answered, I'll be happy now or later. But if you're short of time, we can take it later.
Thank you so much, Navratan. I think we are really running short of time. I
Yes.
think I request the questions to be taken next when he is going to be around.
All right. Thank you.
Thank you so much.
Thank you, sir.
Navratan. Yeah, thank you so much. Can we, over to you.
Yeah. No, I think you have 2 forms which have already been circulated. I think this is the quality audience that we were waiting for. I don't know, these questionnaires or feedback forms are not the one to tick. You may have to take a few minutes to express your views. Kindly please do so. And if you're interested, you can also leave the form with respect to carbon emission studies as well. And with this, I think I'll have to show you a live case. Can you show the two latest photos? Raghu, ask him to show the latest photos. Now you have seen two data which we had captured in the beginning and in between. Okay, this is what we saw or what we read. I'm sorry, the timing has not been reset. We had read 1300 ppm. An hour back, it read 1600. So that means we are almost going into the danger zone. Another 200 ppm rise, that means we are in the danger zone. Can you show the next one? Or this is what the world standard says. 4 to 800 is acceptable or good. 800 to 1200 is fair. That means right from morning, we have been in fair environment. Or sorry, poor environment. We started with fair, we got into poor because our reading read around 1300. And we still continue to be there, and we are almost reaching the border, 1600 now. Charge. Now it is almost reading around 1700 as of now. Now what I wanted to say is, temperature is cool. We are now at around 25 degrees, but the ppm level has gone up. Maybe once you move out of this hall, you will find the difference. And on this, I think Mr. Rakesh Sai, who has been an expert in indoor air quality or air conditioning systems, will tell the impact on this. Extempore bolna hai. Prepared nahi karna hai.
I don't know. He is calling me an expert. I can only say that what happens is, as the carbon dioxide level increases, the blood's efficiency or blood's ability to absorb carbon dioxide is more than oxygen, unfortunately. And if people who have been sitting since morning, they would have already got or already started feeling a little bit of headache by now. This happens because your carbon dioxide level has been absorbed by the blood. And slowly, if it crosses that limit, actually all these limits are for 8 hours of exposure, okay? So you don't get scared. 8 hours of exposure. If you are continuously operating in these zones for 8 hours, that's when you will have the health issues. Continuously 8 hours every day kind of thing. So certain things are also politically motivated for presentations. Fact is that if your 2-3 things happen when carbon dioxide goes into your bloodstream, one is your ability to think reduces or slows down. You feel sluggish. You feel tired, your leg cramps would have started if people would have been since morning. I'm lucky I came slightly late. But these are 2-3 things which happens. And if it continuously goes on, carbon dioxide, also some portion of carbon monoxide goes in. And these kind of environments with a lot of carpets and all will also be releasing some VOCs, which is volatile organic compounds, because of the adhesives that they use. That is carcinogenic, but this carbon dioxide is only, and within 5 minutes of your going out and when you come back to this 400, 800 zone, this effect goes off. So don't get scared by Mallikarjun, it's okay. It's a warning that we are delaying, so we should move it fast. He has very politically brought it in.
Can we, Mallikarjun, can we go for the photo shoot and then break? Yeah, please. I think with this we are concluding the session.
We are almost end of it.
Yeah, thank you so much
for
patiently listening to this. And as we rightly said earlier, this is our first step towards this journey, important journey, and we have wonderful support from Fema. But more to mention is that I think the Cradle and Cassia is going to be an important partner in this whole journey. Looking forward to work with you all and have you all in the next journeys as well. Thank you so much from the Indo-German Chamber of Commerce and Fema as well. Yeah, please over to you. Monica ji, yeah. Should we call everyone here on stage?
Sir, kindly leave the feedback forms on the table, we'll collect them.
Yeah. Can we all have everyone here on the stage and then so that we can have a group photo picture? We are a little thin crowd, but yes, I think we still need this moment to be captured. And then we will go for the.
Come. That is.